Welcome back, everyone. We are here now for the official part of the Azure Solutions Architect Expert Training. If you'll recall, last week, what we did was cloud computing fundamentals. We covered Azure fundamentals. We covered the underlying architecture of some of these technologies, like virtual machines and containers, and so many other things. Now we're going to spend this week focusing on preparing for the actual certification, that Azure Solutions Architect Expert certification, that AZ305 exam. We will walk through the content to prepare you for that exam. Now that we know you actually know something about cloud computing, and why do we do it this way? Well, I've interviewed well over 1,000 AWS certified people and Azure certified people, and they didn't know what cloud computing was despite having fancy certifications. So we did our first week to make sure you all had the good fundamentals. And now we're going to get into preparation for the Azure Solutions Architect Expert exam. So this should be a fun week. Admittedly, when we do this, it's going to feel like it's a marketing message coming from the cloud provider, because that's what these certifications are to a certain degree. But it's your knowledge that gets you hired. It's your capabilities that gets you hired. But a certification will help you get an interview, and the Azure Solutions Architect Expert certification is a nice certification to help you get that interview. So we will begin. Like we do any boot camp, we'll speak for 20 to 30 minutes. After we speak for 20 to 30 minutes, we will answer questions. So make sure you do so. So if you wanted to get hands-on in Azure, there are a tremendous number of free labs that my team made for you. And you can go sign up for them at any time you want. Work through those labs at your leisure. They're simple follow-along labs. And my team just dropped that in the chat box, as well as the description of this video. So go get them so you can do some more. Because we only have 2 weeks in training, and I want to make sure you understand the technology. But you can do all these labs at any time that is convenient for you. Also want to let you know that on Thursday, we're going to have a How to Get Your First Cloud Job webinar. And in this webinar, I'm going to tell you how I got my first tech job, how I transitioned careers, the things you need to know to transition careers. And I don't care if you're going from an engineer to an architect, or a physician or a nurse to an architect. It doesn't matter. You're transitioning careers. So we're going to teach you how to do it. And all the skills that you actually need will cover what we do, and it's completely free. In the description of all of our videos, you can find things to help you, like cloud architect interview questions, for example, if you desire, or AI architect interview questions, preparations for your interview and what to do and how to prepare for it. And so many more free guides are in the descriptions of our YouTube videos. So go out there and collect some free things. We really want to do anything we can to help you for your career. Now, I come from medicine, and we always have to make sure that the person is there, they're awake, they're oriented. And that's why if somebody falls down, they ask you, what time is it? Where are you? Those kinds of things. So I want to know you're here. So let me know you're here by typing hashtag AZ305 or Azure Solutions Architect Expert in the chat box. And when I see a bunch of them coming in, I know you're awake. I know I've been woke up this morning. I went to PT, and after PT, I've been all excited about doing this. So I love doing these free training sessions. So let me know you're awake with an AZ305 with a hashtag or an Azure Solutions Architect Expert, and we will begin. Once I start seeing some of these things pop in, tell a friend, tell them to join us, because we really love. Okay, I see one coming in from Angelica. Nice name. Valeria, Victoria, fantastic. I know you're awake. And John M. Okay, great. So that's great. And in addition to this, I like to know where you're from. Pop that in the chat box as well. I am in South Florida today, in Port St. Lucie. So that's where I am at today. Where are you? I can tell you it's nice and hot and sunny where I'm at. Of course, it's hot and sunny every day, except when it's a thunderstorm or a hurricane or something like that around here. So wonderful. Okay, you're here. So we'll begin the content now. And again, this is going to be more of the official type training. So it's going to look and feel more certification oriented than what we like to do, which is talk about the tech and how to use the tech and how to apply the tech. So we will begin. Now, because I want to cover this for a certification, I'm going to cover it from the beginning, the way Microsoft actually teaches it in their official training. So we'll begin by, what is Microsoft Azure? Microsoft Azure is a cloud computing platform, and it provides a wide variety of technology services like computing, analytics, storage, and network. Remember, cloud computing is just renting space in somebody else's data center. And what exists in a data center? Networking gear, storage gear, servers, load balancers, physical firewalls. And Azure manages a global infrastructure, meaning for the most part, they've got data centers all over the world and they've got high-speed networking between them. And for the most part, there's a couple types of services that we talk about in cloud computing. And because this is a certification preparation as opposed to more knowledge based, we're going to cover them. So we have infrastructure as a service. And what is that really? That is providing rental equivalents of exactly what you have in the data center. So a virtual machine in the data center, a virtual machine in the cloud. Virtual router in the data center, virtual router in the cloud. And with infrastructure as a service, you have the most access and the most control, and generally speaking, the best performance. But you have to manage more of it yourself. The next type of platform we'll talk about is platform as a service. And what is this really? Well, realistically speaking, the infrastructure is mostly taking care of you. So it's less about thinking about the underlying servers and the underlying storage. Basically, you upload your code and it typically works. So your application developers are pushing their code there and nobody really knows what's going on under the hood for the most part, which is not a good thing from a control perspective, not necessarily an optimal thing from a performance perspective. But if you don't know and you don't want something complex, it works. And then the next type of thing we can see on cloud platforms is software as a service. So basically, somebody's delivering you software over the internet or over your internet on the cloud, and you pay. So Microsoft 365, Microsoft Word, Excel, PowerPoint, Outlook, that sort of thing, that is a software as a service platform. So with Azure, we've got a wide range of these services. Under compute, you can think about virtual machines. You can think of containers. You can think of functions as a service, for example. And we'll talk much more about all these technologies. Under storage, you can think about object storage or blob, Azure file storage or disk storage like block storage for your managed disks that you're going to use for your virtual machine. Under databases, obviously you can run any database you want on a virtual machine. But you can also use the Azure SQL database, which is an Azure proprietary database, which proprietary is not great in a multi-cloud world. Azure Cosmos database, which again is a proprietary NoSQL database, and Azure databases for Postgres, MySQL. You will get networking services, and what are that? Well, there'll be virtual routers, virtual load balancers, content delivering networks. There'll be some machine learning services, such as Azure Machine Learning or Cognitive Services, which are going to be pre-made models that you can use for your machine learning. Of course, you could always build them yourself based upon your business's needs. IoT services, which are related to Internet of Things devices, like your IP-enabled refrigerator that talks to you, or little mini weather sensors that are out there, or cars that are communicating to something else. That's typically your Internet of Things type thing. And with that, you need your IoT devices or the sensors that are going there. You typically need a hub, and you've got like the Azure IoT Hub and IoT Central to collect all this data and terminate those services. Azure provides DevOps services, so things like Azure pipelines, Azure repos, and we'll talk much more about these as we go through the training, even though DevOps has absolutely nothing to do with architecture. And we'll talk about things like security and identity. Understand most of your security things won't be coming from the cloud providers. They'll be coming from security services, but there'll be things like Azure Active Directory for your identity and access management, which Azure will typically provide. They'll typically be a place to store your keys like the Azure Key Vault, and there's going to be a security center, which, everything, including your computer has, which can kind of give you some junior level security information about what you've got going on. Now, of course, Azure works in multi-cloud environments, which 98% of organizations use. And it also supports hybrid clouds, meaning you can have your data center connected to the cloud. And guess what? You can access your resources on the cloud. The cloud can access resources in your data center. So lots of flexibility. We love hybrid clouds because they give you the best performance, and they typically cost much less than a full cloud environment for systems that run all the time. When we think about cloud computing, we have to think about the flexibility and the scalability. The limitation in the data center is, typically speaking, scalability. You only have as much compute capacity as you have servers. And in the cloud, It's kind of like that movie where they said, build it and they will come, where they've just spent a ton of money buying stuff that they think you're going to come there for. So you got extra capacity, and it's very easy and very agile to leverage it. So that's one of the things we're talking about. When we deal with the cloud providers, they do what they can to try and make security as good as it can be. And generally speaking, cloud computing is almost as secure as the data center. Some would call it more secure, but they don't really understand security. But it gets you almost as secure as the data center. Cloud providers have a lot of tools for developers to work with directly and not have to deal with all the underlying infrastructure people if they wanted to go that way. And generally speaking, because we're dealing with a cloud provider and all these things have logs, they typically have a centralized logging environment for us to get our analytics and insights from seeing what's going on with our things. And they also have a lot of analytics tools. We can scale up on the cloud, down on the cloud on demand. And in certain cases, that can actually reduce costs. Usually cloud computing costs more. But if we deal with certain things like a website for a retailer that realistically speaking, only needs this much capacity 90% of the year and this much capacity the rest for a small period of time, that's where cloud computing may be cheaper, because normally speaking, we have to build for max capacity and the rest of the time systems are idle. And with cloud computing, we can build on average capacity and then scale out as needed, which is quite good. So we'll be talking about all of these offerings. And we'll talk about deploying and managing virtual machines, building and hosting web applications, the things that are related to the deployment of microservices, storage and management of data, AI and machine learning solutions, because you can do this on there, enhancing security and compliance, automating workflows, visualizing data with various tools like Power BI, development and testing of applications. Microsoft, as I mentioned, works well with the hybrid clouds like any other provider. They've got some blockchain technology, which of course you can do in all cloud providers, although blockchain is typically distributed ledgers versus centralized ledgers like you'd have in the cloud. But the cloud providers enable you to be more agile with DevOps practices, and those are the types of things that we'll talk about. So we're going to start from the beginning, because this is a certification exam, with Azure accounts. So in order to start working on Azure, you have to create an account. So realistically speaking, that's called by buying a subscription. And the subscription that you buy is going to be your access key to the cloud platform, meaning you've got a subscription, you'll be able to provision and use services. So let's talk a little bit about getting started and creating your Azure account. Realistically speaking, you're going to create an account for the business. And you may want to create additional subscriptions for the business. So you might want one account for production, maybe another account for a sales team, another account for a marketing team, and keep these as potentially separate accounts. This could help you figure out which department is using which budget across different parts of your company. Now, each subscription will be inside of a container for billing for resource management purposes, and that will enable you to organize and figure out what you're spending, where it's being spent. Like any other subscription service or any cloud provider, you can set a spending limit, like a budget. You can set off alerts and notifications when you spend a certain amount. You can apply policies of who can do what, and you can assign roles to manage access with positions. So basically, that's what we're really talking about on getting started with your Azure account. And if you're a student, you can create an Azure free account and start working on certain things. So keep that in the back of your mind. So now let's talk about the Azure physical infrastructure. So Azure has data centers all over the world. We have to understand that a data center is this. It is a huge room filled with the following. A lot of power coming in, because these servers demand power, and more power. We have nowhere close to the amount of power we need to actually power our data centers based upon AI and machine learning, let alone any other things that we wanted to try to make electric. We are so short on power for current data center needs, and AI is just going to make that a much higher. And when you walk into a data center, you're typically dealing in an environment where there's some raised floors, so wiring could go underneath the ground. There are going to be a ton of air conditioners. You're going to put your winter coat on when you walk into a data center because it's going to be freezing inside because the servers typically work better when it's cool. There's going to be these racks, and they're going to be racked from floor to the ceiling from 100 meters, 200 meters, 300 meters long, or more, potentially even 1,000 meters long and 1,000 meters wide. And they will have racks that are going to have servers that look like pizza box racked from floor to ceiling. And they will be plugged into routers and switches. And there will be generators and backup generators and batteries. So basically a room filled with more computers than you could possibly ever dream. That's a data center. And when you deal with these cloud providers, they have a global reach, meaning they manage all these data centers 24 hours a day, 7 days a week. And then they have high-speed networking between data centers. So I might actually draw that out and kind of show you what that would look like. And then regarding these data centers, you can't get in them. So these data centers are available to Azure. So I kind of hope that makes sense. So maybe this will kind of help bring this into fruition. Let me draw a little slide for you here. So you're going to have a data center, and I've been setting up these cloud providers since as long as I can remember. You've got a data center. You're going to have another data center. You're going to have another data center. And what will happen between these data centers are you're going to have multiple routers in each data center. And typically a circle is a router. And you can't have a single router because that would be a single point of failure. And I want everybody to understand this, because if you don't understand this, you're not going to understand why you can't have a high availability system on a single cloud. And what you'll have is you're going to have connections from everybody to everybody for the most part. I'll give you an example here. And these are going to be very high speed connections between these data centers, 10 gig, 100 gig, that kind of thing. Very powerful. And they may actually have, in certain cases, multiple 100 gig links between these data centers, especially if they're going to be local to each other. Oh, I didn't mean to do that. It's hard to draw networking stuff sometimes on the fly, but this will give you a concept of what it's going to make sense. And there's a reason I want to show you this. Oops. Some people draw a lot of pictures. When I was younger and I got my first architect job, I thought I was going to be drawing pictures all the time. And then I realized that we didn't draw that many pictures as architects. Typically speaking, if it got pretty important, we drew some, and then we would draw it on a napkin sketch and send it to the graphics team. And I'm just going to add a couple more links here. So I'm not going to get them all right now to full. So basically speaking, what you got is you've got your data center here. You've got, let's call this data center 1, data center 2, and data center 3. Each data center is going to be called an availability zone. And if all of these are in the same geographical area, this is going to be called a region. So a data center is called an availability zone, but it's just a data center. And when they're all together, bear with me, they make up a region. So this is your global region. These are your data centers. They typically have what's called dark fiber connections in between them. And they typically run what's called an interior gateway protocol underneath them. It's a routing protocol. Something like OSPF or IS-IS is going to be running between them. And what that happens is this tells this data center how to reach the systems in here. This tells this data center how to reach the systems in, say, data center 2. And if a link breaks, the routing protocols will reroute the data so all these systems are there. Note something. What happens in this data center is going to affect these other data centers, because if a link flaps or systems go up and down depending upon the way the systems are routed or the IP addressing are, it's like a contagion. We can have a problem in data center 1 and it can take out data center 2 and 3. So there's that. So data center availability zone, large geographic area is going to be a region. So hope this makes sense. And then after this, what's going to happen is we're going to actually show you the regions and the such. So let's call this, I'm going to call this an interior gateway protocol, otherwise known as IGP. And I'm going to use one that's typically OSPF/IS-IS. These are the two giant link state protocols that work across cloud providers. And that's really what we're doing. So availability zone data center, generally speaking, region, multiple data centers, large geographic area. Now we're going to talk about a region. An Azure region is going to be a geographic area that has one or more data centers. Regions are designed to offer some degree of redundancy by spreading your systems across parts of the world. Now, I'll talk about why that can work sometimes and why it won't in a minute. But I also want to talk about Azure region pairs. So most Azure regions are paired with another region in the same geography. The purpose of the regions is to facilitate replication across geographic areas. So by doing so, you've got something in the East Coast and the West Coast, you replicate it on both. And if something happens with the East Coast system to the US, it hopefully, we'll talk about why it's hopefully, doesn't affect the systems on the West Coast. But we'll show you in a minute why it can. There are also what's called sovereign regions. And what's a sovereign region? Well, there's data sovereignty laws. For example, you have some businesses, let's say they're in Europe, and their data cannot be stored outside of Europe. So that would be a sovereign region where you'd need to keep it there. Now, a lot of them are based upon governmental or legal requirements. For example, the US military is not going to put their systems on the same cloud in the same regions as everybody else's systems due to security. They're not willing to do it for security, but we typically do as a business. So there's a US Department of Defense region, and there's a US government region, there's a US government region in Iowa, and etc. There are also regions in China, but Microsoft does not manage these data centers. They are managed by a company called 21VNet. Then they have to comply with Chinese regulations. So keep that in the back of your mind. Here is why that you can't use multiple availability zones and multiple regions and expect that it's going to work and not have an outage. So let's pretend this is a region. Let me just do this real quick. No fill. Inside each region, we're going to have a data center called an availability zone. And the availability zones are going to have high-speed networking between them. And they're going to be running that interior gateway routing protocol, such as OSPF. So I'm just going to put IGP here. And that's how all these availability zones in a region are going to understand how they can reach each other. Now, let's say we have multiple regions. Typically speaking, what you do in networking is as follows. Each region runs its own independent interior gateway routing protocol like OSPF to exchange routes for all the things inside that region. And I'm going to just use one router for simplicity. There'll be more routers, and they typically have routers at each region. And these routers run an exterior gateway routing protocol called BGP. So what happens is all of these entities typically run BGP between them. And it's typically an exterior version of BGP. So what makes it exterior? So I'm going to use private AS numbers, but I'll show you. If this is autonomous system number AS 65312, and this is 65313, and this is 65314. It's the wrong one. It's hard. It's not always the easiest thing to copy something. Let me copy it over here. And they'll be running eBGP between them. So eBGP between all links. And by using exterior BGP, each one of these systems can say where they're going to be accepting routes from, what have you, what's acceptable, what's not. So that's how they try to isolate these regions from one another. But what happens if something bad happens in this region, for example, and something crazy goes on with the routing, it can propagate, depending upon how the architecture is set up, to the rest of the regions. So a region in Japan has the potential to actually take down regions in the United States, for example. So I kind of hope that makes sense. The other thing that could happen, which could take a single cloud down, is you could get a major DDoS attack anywhere on these systems, and that can take it down. Or typically speaking, when you've got a cloud, there's going to be this control plane that takes advantage of the entire cloud. I'll call this the control plane. And that's kind of like when you log into a management console and do something, and it automatically moves things to the systems. It's like a routing protocol which controls traffic flow through the network. It's also no different than Kubernetes orchestrating the containers. If this control plane goes away, or it gets hacked, or falls, or crashes, the entire cloud goes down. Problem that happens in one region could potentially spread to the other region based upon the BGP type policies and the networking policies that are there. And of course, you can get a DDoS attack, and that can take down anything. Although Azure's been doing real well against DDoS. So we talked about this. So the way they group data centers in a region usually, but not always, will resolve a single data center outage. Something happened to a single data center, for example, where it basically had a fire inside of that data center, and the systems went down, but it was shut down. Theoretically, the other data centers or availability zones in the region will be okay. But all that flapping up and down in one of those data centers can have an impact on the routing based upon how well it's actually being there. So I kind of hope that makes sense. So let's talk a little bit more about Azure resources. And each resource, when we talk about Azure resources, is going to represent a specific component, such as a virtual machine, or a storage account, or a database, or a networking interface. And we'll obviously get into there. And typically speaking, types of resources are going to fall into their category of compute, like a container, a virtual machine, function as a service, which we talked about in our intro fundamental section, storage, block storage, object storage, file storage, what's on the server itself, databases, what database that might you be using, networking, things like virtual routers, network security groups, firewalls, that kind of thing. Load balancers typically falls under networking. Identity, which is who are you? What are you allowed to do in keeping track of it? Things like Azure AD, otherwise known as Microsoft Entra ID now. Identity. Monitoring, which would be tools to let you see what's going on, as well as logging type things, and management, which are tools to be able to control certain parts of your system. So we'll briefly talk about, we talked about that. Azure Resource, I mentioned Azure Resource Groups. So let's talk about lifecycle management. What does this mean? Resources can be created, they can be updated, they can be deleted. Resources can be managed through the Azure Resource Manager templates, the CLI, Azure PowerShell, the Azure portal, and each resource we can actually put tags. And the tags can be specific resource properties like where it's located, the configuration, what it's relevant to, so we can figure it out after the fact. Okay, well, we're going to get into compute, and I want to have some fun with that. But real quick, I want to see if there's any questions before we go to the next section. As you can tell, last week we got heavy on the fundamentals, but this week we're truly trying to focus on making sure that you can pass the exam. So, Chris, are there any questions so far? Can multiple availability zones reside in the same data center, or do they always have to be separate? In Azure and most cloud providers, availability zones have to be in separate data centers. But, they could be, across a parking lot from each other, but they have to be separate. The whole point of separating these availability zones is that each building is isolated. If one building goes up on fire, for example, or somebody breaks into a building and you needed to shut it down. So typically a different power on each data center, meaning different transformers and different power coming in, different cooling systems, different networking systems that are going to exchange information between systems, but no, they're going to be separate. And that's the whole point of the availability zone, is to add a layer of availability with it by being separate. Great question there. Can be paired region to improve network performance? So paired regions are for disaster recovery, they're for data redundancy, they're for availability, but they are not for enhanced performance. The point of making them geographically resilient is to ensure resilience. Now, there are times where if you've got half of your systems in one side of the country and another that you might be a little closer, that would actually work. But realistically speaking, that's kind of not. That's they're typically speaking, that's not there to improve performance. Are availability zones connected by fiber optic cables or wireless? So, Kojo, nothing that matters will ever be over wireless. So that's something to remember. Every server is physically plugged in. We only use wireless if we have no choice, like an Internet of Things device. Wireless performance is not guaranteed. It's subject to traffic congestion and all kinds of things. They don't have their own independent bandwidth. So whenever it matters, we will use a cable. If the cable is less than 100 meters, we can potentially use a copper wire. Anytime it's over 100 meters, we must use a fiber optic connection. Short distances fiber optics, we can use something called single mode fiber, which is cheapest. I'm sorry, short distance, we can use multi-mode fiber, which is the cheapest. Long distances will always be single mode fiber. So realistically speaking, these are always going to be fiber optic connections. Nice question. Can I explain virtual hub and when? Yes, when we get to that concept, we haven't even started the networking section. We can actually get to that. But right now, we're talking about regions and availability zones, etc. Will IBGP or EBGP run across two data centers located in the same campus but separated by distance? So, it depends on what we're trying to do. EBGP is to use between external entities. So, if I'm going to connect to Verizon or to AWS, from me, I use EBGP. So there's that. Having said that, if I wanted to connect to AT&T, since I mentioned Verizon externally, I would connect to that. If I need to carry Verizon and AT&T's routes across my network because I wanted to provide transit for the internet, or I wanted the internet going through me, then I must run an IBGP in my systems to carry the externally learned routes there. So typically speaking, but we can't run IBGP without an interior gateway protocol such as OSPF. We have to remember that interior gateway protocols like OSPF, which we use internal network, are really fast. Cable gets cut and they recalculate their systems relatively quickly. When we use BGP, it is going to be a much slower process. So we only use BGP routes if and when we actually need so. So I'll give you an example of when we might want to do it, because that's a great question. Let me draw it out for you. So if we had this environment where we've got one internet service provider, ISP A, and we've got ISP B, and then we have ISP C here. This goes back more into that transit of routing kind of discussion we had. Let's say ISP C had a link to ISP A, and ISP C had a link to ISP B. If ISP B's routes are sent via EBGP to ISP C, which they will, and ISP C runs IBGP and carries all of those, say, 800,000 routes that it learned from ISP B, and then sends those routes via EBGP to ISP A, and then vice versa occurs, then what we have is what's called transit, and transitive routing, meaning ISP A will be able to reach ISP B through ISP C. But if we don't want to provide transit between ISP A and ISP B through C, we either have to set what's called a community no export, which basically means when ISP C learns routes from B's, don't give those routes to ISP A. So that would be one of the things we would think about in our internet routing architecture. That would be one way. We could tag it with the community no export. We could also set up a route filter where we take ISP B's routes in and then we don't export them to ISP C, something like a distribute list or a prefix list, what have you, if that was the way our engineers wanted to do it. But if we needed to provide transit, we would need to basically do some form of IBGP peering. But that's only to carry their routes across our system. And that's typically when you would do that. So that's a really great question there, Leonard. All right. Well, if there are no questions, let me know you're awake, you're alert, and you're oriented by giving me a hashtag Azure Solutions Architect Expert Bootcamp or a hashtag AZ305. I'd like to know you're here. If you've just joined us and you haven't been for the first week, go back. The first week gives you fundamentals on cloud computing and the underlying technology. This week is more focused on official Azure type training, which is more focused on passing the exam. And is because that's what the goal here is. The first week we try to teach you how some of the technology works. I have a free webinar this Thursday, like we do most Thursdays, to help you get your first technology job. It's something that I love doing. I love getting people great jobs. It's just something I do. I've done for the last 20 years. So, and now we'll get back to the concept. So now we're going to begin by discussing compute and networking services. And because we're following more the official Azure curriculum this week, where last week was actually focused more on learning as opposed to just passing an exam, we're going to repeat certain things several times as they get into different contexts. So bear in mind, we're now going to begin with compute and networking services. And we'll begin with the compute. That's the technology that actually does the work. So we'll begin with virtual machines, and we'll talk about them. If you recall, a virtual machine, and maybe I'll draw it out, is basically your typical server environment. You can always tell somebody that took a certification and doesn't understand technology because they hear about an EC2 instance and they get excited, or an Azure virtual machine or a Google Compute Engine instance and get excited. We've had this stuff for decades. If you recall, you have the server, and last week you saw me, I actually opened up a server and I showed you the DRAM and I showed you the tool processors that were there and the storage and the PCI ports and things like PCI ports and things like that. But what you're going on here is, remember, you've got your server, you've got a hypervisor, and then what you do is you create, your virtual machines over here. Here's your virtual machine, which is going to have a certain number of cores, like let's say 8 cores, 64 gigs of DRAM. And then that machine itself will have its own operating system, like Linux. And then that will have, if you'll recall, the application dependencies, maybe like a .NET framework or something like that for organizations that still use that. And then it will have your app code. And that's realistically what we're speaking. Remember that. So when we talk about Azure virtual machines, that's what we're referring to. The key with using a virtual machine, and this is where the architectural considerations we're describing, is it's exactly what you're using in the data center in most cases, which means you could just take your data center virtual machine, move it to the cloud, and do nothing, and you are up and you are running. When you use a virtual machine, you have control. You know what those resources are in that virtual machine. That means you've got total control. You can control the operating system and lock it down to be really tightly secured if you want. You can run any custom software you want on it. You can pick the number of CPU cores, the amount of DRAM, the type of networking performance. And realistically here, this is the highest performance option. And it's no different than a virtual machine in the data center, other than you don't have to buy the physical server itself. Now, understand, when you rent a virtual machine in the cloud, it's going to cost you a lot more than the server itself. For example, my team and I priced a $300,000 server from Dell, maxed out with about 4 terabytes of DRAM and about 192 cores. It was about 300 grand. It cost over 4 years about $6 million to run that same $300,000 server in the cloud, because you're renting it, which means they've got to buy the same stuff, pay their sales team, manage it, operate it, and then re-rent it to you. So keep that in the back of your mind. It's very easy with a virtual machine to take an image and just relaunch it. And virtual machines on the cloud take literally minutes or less to create. So these are really, really good architectural options. Nothing is going to scale better than a virtual machine because it's all a server, or as much of the server as you want. So we may use a single virtual machine for testing or development, but we're going to group our virtual machines together if it's a high availability system, because we can have 10 virtual machines in a group, leverage the performance of 10 of them, lose one, and still have 9. So that's why we use more than one. There's a rule in high availability system design. 1 is none, meaning 1 is nothing. 2 is 1, meaning you got 1, and 3 is greater than 2. So whenever you think high availability, whenever you think how many clouds, 1 is nothing, 2 is 1, and 3 is greater than 2. And careers that literally are dependent upon that typically always follow that philosophy. That's why airplanes have more than one engine, for example. You don't want them falling out of the sky. So keep that. And we can do something called a managed grouping as well on Azure, where that gives us like scale sets and availability sets, which I'll talk about right now. So what is a virtual machine scale set? Well, a virtual machine scale set is going to enable you to create and manage a group of identical load balanced virtual machines. So a whole bunch of web servers that are all identical: CPU, disk performance, network performance, what have you. It's automated because you basically set it up, and Azure will automate the configuration, updates to the system. It'll provide the networking and the routing between your systems. You know, we can basically have it set up where it adds capacity as needed, which is good. But remember, when we're dealing with any kind of auto scaling, it's going to take some time. And, you know, one of the things people like to ask people in interview questions is, okay, you've got a website for a global retailer. What do you do before Christmas? And the point is, they want you to know that you're not going to just let auto scaling take it and lose a bunch of orders when a sales email goes out. That you're going to pre-warm your load balancers, what you actually have, and tell it to scale and add capacity before you need it. And that way you don't lose orders, because auto scaling to get to max capacity could take 30 minutes if you need a lot of capacity, and you wouldn't want to lose orders for 30 minutes if you're a global retailer and you send a major Christmas sale thing going on. So keep that in the back of your mind. These machines will automatically be load balanced if you put them in a virtual machine scale set, because that's the only way you're going to load balance across multiple virtual machines and make it look like a single virtual machine is with a load balancer. And we can also do some large scale services here, which is perfect for big compute, big data, and container oriented workloads. So that's a scale set. Basically, auto scale and group, and AWS just scale out, add the capacity as needed. We also have the concept of a virtual machine availability set. And this is great. It's going to help increase the availability and the resiliency of your system, because it will group your systems. And we've got 2 different grouping methods we can use. We can use something called an update domain. And basically, this is going to be a group of virtual machines. They can be rebooted together. You can apply updates to them together, and it doesn't affect the entire set, which is kind of cool. And we also have the concept of a fault domain, which is groups of virtual machines by a common power source and different power sources and switches to protect against network failures. So think about it that way. And for no additional cost, you can configure these availability sets because, you know, they're basically going to make sure you've got the capacity you need and hopefully a higher availability situation. Why is it no additional cost? Because you're paying for more virtual machines when this happens. So it's the best case scenario for them. You increase your availability and you pay more. So let's talk about when you would really use a virtual machine in the cloud. Well, if you've got a monolithic application, but you're going to run on a virtual machine, that might be a great place to test it and develop it on a single virtual machine. you may actually want to run our applications on a virtual machine because you got the most control and you've got the most power. So if I need a ton of capacity, I'm probably going to put it on a virtual machine or a group of virtual machines. What if I have a data center working really great right now? And in the data center, my systems are paid for, they're running, the performance is great, and I'm a little short of capacity at a certain time during the years. Well, I keep my data center and I set it up to add capacity and expand dynamically on the cloud. And that way I get the agility of the cloud and the cost savings of the data center and the performance of the data center, which is great. I might also use them for disaster recovery. I can take my data center and stick it on Azure in a disaster recovery environment and put it all on virtual machines. And if I need to transfer data to the cloud, it will scale out over the course of, say, 45 minutes, and I'll have a fully functional other environment. So that's that. Where else would we use a lot of virtual machines? Well, I got a virtual machine in the data center, right? I want to go to the cloud. I don't want to do anything that we need to do. So here's what I need to do. I take my virtual machine image in my data center. I copy it over to the cloud over my direct connection, express route, direct interconnect, private line, whatever you feel like calling it based upon your cloud provider. And poof, you are up and you are running. That's called the lift and shift. It's also one of the most common migrations to the cloud. Why? Because you take your entire data center as is, move it over to the cloud as is, change absolutely nothing because all the cloud is a virtual version of what you had. And then companies find out that their costs go up 200 to 300%. But, so be it. Now, David Lithicum's number, and I trust David. He and I talk architecture almost every day. A lot of respect for his work. His research shows the cloud costs 2.5 times on average what it did in the data center. And that's in line with what I've actually seen. So that is the virtual machine. Now, the next thing we're going to talk about, Azure Virtual Desktops. For a while, this was the Windows on demand, and everybody was all excited about this. You could rent a Windows notebook with a quarter of the capacity of your notebook for $150 a month on the cloud, and then you didn't have to worry about your system. You pay 12 months with that, it would cost you $2,000, and it wouldn't have even a quarter of the capacity of a notebook. But there are times where virtual desktops are awesome. So first, we'll explain what a virtual desktop is, and then we'll walk you through. So we'll have a virtual desktop over here. Let's try to, let me get a user. So I sent a really cute computer user over here today. So we're going to have the user. She's one of my favorite users. Her name is Cindy. And see, normally, Cindy does her work by the following. She goes to one of the, you don't want to know how many computers sit in this house, and she normally types on her computer. So normally this is Cindy's PC. So normally speaking, if Cindy wants to go out there, she puts her paws on her local PC that's in front of them, and she connects to resources.
Mike, you need to share, please.
Thank you. Okay, so in a normal environment, we got this cute little cat, Cindy. See how pretty she is? That's my little girl. And she loves to use the computer. She loves to walk on my keyboard. She loves using computers. She thinks it's fun. So generally speaking, in a normal world, Cindy does all the work on her PC. And let's say she wanted to go to a website over here. Let's say website. What she does is she goes to her local computer. Her local computer does the website, and then the website responds, and that works. Now, oops, I don't even know what happened there. Bear with me a second. Bear with me. Okay, so we'll go back to where we were at. So Cindy goes to the website, but all the work is done on Cindy's PC. This is doing all the work. And that's something that's pretty important to remember. In a normal environment, your PC is doing the work. Now, there are times where, let's say Cindy's PC was, let's say, really old now. So it's old and slow. And this PC is now too old and too slow to do anything good. But the PC has enough to say open a web browser, and she wants to use what's called the virtual desktop. So here, what we have in a virtual desktop is we've got a data center, and let's cut this down. So this could be the data center or the cloud, and I'll show you why we may actually use them. So this is, say, the cloud, and it's sitting in an availability zone. And there's a server inside of here. This is a virtual desktop. And where does the virtual desktop sit? Guess what? On a virtual machine. And now what we have is, because Cindy's PC is old and slow, she remote controls this virtual desktop out here. And then that virtual desktop either goes out to the internet and gets information, not Cindy's PC. So Cindy is going here. She's requesting the work of this computer, and this computer is going out to the internet and getting it done. And then it and it displays the screen of this virtual desktop on Cindy's PC. So that is another way that these can be used. And that's what most people were talking about, where they were talking about this Windows Cloud PC. And anybody that looked at it and said, why would I get a 2-core PC in the cloud and pay more than I would for a 16-core notebook? It's crazy. But here's where it's not, and here's where these virtual desktops work out real well. So let's say now, for example, that in our cloud availability zone that we're dealing with here, we have a very high security environment. So instead, this will be a cloud AZ, and let's just say this is a bank's. We're going to change this now to a bank's VPC or VNet, because it really doesn't matter which cloud provider. And let's say the bank has a trading system in here. Let's call this a trading system. Let's say the bank has a finance system over here. So now what we can do, which makes this kind of interesting, is Cindy can remote access VPN into wherever the data center is, VNet, VPC. The virtual desktop will go to the trading system. It will go to the finance system, and none of the data will ever leave the data center. And it will just send the screen back to Cindy's PC. And that way, all the secret sauce going in here, all that high security, high proprietary things that are going on are all directly in here. And by doing so, none of the data ever left. So if you hear about data sovereignty or not allowing data to leave a certain environment, if you're in a highly regulated environment and you can't lose data, they use these virtual desktops. So you may have heard about Citrix, people using remote, like you're going to the hospital's terminal was there, you would VPN in and then be able to remote control their system. That's why they were doing this in banks. That's why they were doing this kind of stuff in hospitals, because it would keep all the security and the secure information off of the internet. And the only thing that was sent was the video to the screen. So I kind of hope that makes sense. And now we talked about that, let's talk about Azure Virtual Desktop. But it's important to me that you actually understand what they actually are. So Azure Virtual Desktop is going to be basically a desktop virtualization service running on the cloud. It's just a cloud-hosted Windows PC sitting on a virtual machine, which you can access from any location. So why might you do this? Well, let's say you absolutely need you need the application to run on Windows, no matter what. But you're a user like me and you like using your Mac. Well, I remote control that Windows application. I have no problem. A developer or a data scientist has a Linux system, but they need something where they're going to write a Word document or a PowerPoint or draw a Visio diagram. They can virtual desktop in and they can do it, along with keep your banking information there. So there's that. It's also centralized management. Well, think about how easy it is from an administration perspective. I'm not worried that much on your VPCs, other than on your local PC that you use for remote access, other than you've got secure access to the system, and you can't create any worms or viruses or what have you, and the data never leaves the system. I don't have to worry about data on your notebook. Your notebook gets stolen. I have to think about remote wipes. It's all centralized data, centralized management. So that's nice. I can set up a multi-factor authentication for you to sign in. I can come up with very granular role-based access controls based upon Active Directory, Enter ID of who can use what. I can separate my data and applications from my local hardware. I don't have to think about what kind of PC is using. They could even do it from their mobile phone. So no confidential data is going to be stolen from our virtual devices because there's no data on them. It's centralized somewhere else. And I can isolate. So there's lots of reasons people would do that. So when it comes to the virtual desktop, it's either going to be on Windows 10 or Windows 11. Multiple users can access the same virtual machine at the same time. So if you wanted people to collaborate, for example, it gives a very good, consistent user experience. And here's the reason why. Every virtual machine on the cloud can be set up for the same performance. And as long as you've got access and the ability to remote control these PCs, it's going to work well. And that's a little different than the traditional client server, where the server is giving information to the clients and the clients have enough power. I'm not saying this is the right solution, but there are times where this is a great use case. It's really great because it's cloud hosted. So when a user's PC gets corrupted, you don't have to go think about reinstalling their applications and operating system because none of it's on there. It enhances security, provides centralized management. You know where your data is, and it's going to be consistent. Somebody installs the wrong thing on their PC, it's not going to affect that stuff on the cloud because it's a different virtual machine. Remote work is a great use case for this. Enhancing security is great, and it tends to scale fairly well. So that's realistically speaking what we're actually talking about. Now we're going into containers again. So before we even touch containers, I want to briefly draw a refresher just in case you weren't here last week. Remember, normally speaking, when it comes to containers, we're going to need something to orchestrate the system. So we always need an orchestration. Realistically speaking, that's Kubernetes. And that's going to be, how many virtual machines do you need? Where are they being deployed? What have you? And at the same time, so let's say our orchestration is over here. And if that's where our orchestration is going to be. And then typically we need something to run the containers. They'll typically sit on a virtual machine or an Azure container interfaces, but we'll talk about it. And basically we'll have the container, we'll have a virtual machine. Let's just say virtual machine for right now. The virtual machine will have something called the container runtime module, like Docker. And then the virtual machine will have what's called the container. And basically what's in the container is an application and its application dependencies. And obviously we will have a tremendous number of we may have a tremendous number of containers sitting on a virtual machine. Now, if you want to go back and learn much more about it, we got into pretty detailed last week when we did this, but that was just a refresher. So let's talk about why people like containers. Well, they tend to be efficient. See, in every virtual machine we talked about, we had to create resources for the virtual machine. Each virtual machine needed its own operating system. Now, I got to tell you, I installed Windows on somebody's computer the other day. And it was a friend of mine. And it was using like 6 gigs of DRAM just for the darn operating system itself. So if I had 10 virtual machines and each one needed 6 gigs just for the operating system itself, that burns 60 gigs of DRAM on the server. But with a container, it's going to pull the operating system dependencies from the operating system that's underneath. But each container is going to be isolated from each other. So I don't need 6 gigs of DRAM just for the operating system. I use DRAM for everything, and it's going to be shared space. So containers typically cost less in terms of the amount of compute resources they need. Less compute resources equal lower cost. Containers are so easy because they're very lightweight. You just transfer the container from point A to point B. Developer has a container running on his Linux system, copies that container to the cloud, and it runs on either a Linux system or it runs in a serverless environment, which is great. We don't really have to manage. We have no operating system to manage for the containers. Containers are designed to be started, stopped, added, scaled very easily, and they're very agile, and they're typically potentially lower cost. Now, if we're just going to go to a complicated container environment for a small amount of containers, it's going to be cheaper to go to a virtual machine. So when its architecture is anything, evaluate all trade-offs and see what's best for our client. Need more control? Use a virtual machine, but it's one of the things to think about. So containers, if you specify, I need 10 of them, and one of them crashes, it'll just add capacity on demand from the control plane. They restart real quickly. And obviously you need a container runtime module, and that's typically Docker or something else. So virtual machines, whole virtual server, operating system, heavier than a container, more power, more control of everything. Container, lightweight, no needed to manage the operating system. They're suitable for a dynamic and a responsive type applications, but smaller stuff as a rule. Containers restart much faster than a virtual machine, typically speaking. So how do we run these? Well, we've got a couple options on the cloud. We can use something called Azure Container Apps, and that's going to be very similar to Azure Container Instances, but pretty much you just upload your code in a platform as a service type environment. It's going to give you your load balancing. It's going to give you scaling capabilities to add and remove capacity. And then we have Azure Kubernetes Service, which is an open standard Kubernetes environment, a container orchestration service. It will manage the lifecycle of your containers, auto scale in and out. Here's the thing to think about. 98% of enterprises are multi-cloud, which means Azure Container Apps won't work in a multi-cloud environment. It also shows that even though Azure Kubernetes Services will be able to manage your containers in multiple clouds, if Azure goes down, you lost your control plane for all your other clouds. So should you use something like this? Probably not if you have a large company that's on more than one cloud, enterprise scale, and 98% of companies that are enterprise scale are on more than one cloud. Probably don't use this here. But for the exam, it's great. So when would you use these Azure Container Service type things or Kubernetes? Well, maybe you've got containers for a microservice architecture, and this could be your control plane. It's going to scale real well. It's going to be simple to think about. But, it's platform as a service. So you lose control. You lose understanding of what's going on underlying hardware, and it doesn't work multi-cloud. But containers themselves are a great form of virtualization. They tend to respond very quickly to changes, and they reboot very quickly. They tend to scale, and it gives you the ability to keep your systems lightweight and efficient. Now, what is serverless? And we're going to talk about serverless computing and Azure functions. So first thing I'm going to tell you right now, there is absolutely no such thing as serverless. It's a made-up marketing term. So what's going to happen is your cloud providers are going to have servers everywhere. Basically, what they're going to have is a rack. It's going to look like this. And what you'll see on these racks are, you're going to see servers racked, a server here, another server, another server. And these things are going to be 1,000 meters long, 1,000 meters wide. And each server is approximately the size of a pizza box, if you're familiar with pizza boxes. Maybe 1 to 2 inches thick. Lots of compute, storage, and memory. And this is what these data centers are going to realistically be looking like. I'll build a couple of racks for you in case you've never seen a server room. And what you're going to see is you're going to see rack after rack after rack. And all of these are going to be servers that are sitting here. And what serverless is basically you put your code into this little thing. And that's now run on any one of these servers that's sitting there in the serverless environment. So the word serverless is the most ridiculous name I've ever seen. It's like a carless car, but you get in your car, you turn your key and drive. It's the same thing, but you just upload your code and it goes, meaning you don't know what server it's on. You don't know what your networking is. You don't have to think about any of it. It's done for you. Give it your code and it runs. That's the serverless function. This is the way an AWS Lambda function runs. This is the way an Azure function runs. This is the way a function as a service runs on a Nutanix cloud or an OpenStack cloud. It's not serverless. It's just you don't think about it. So why do people use these functions? Well, They're great for what's called event-driven architecture. So I got Billy Bob that stores something on our object storage, our blob, our AWS S3, our Google Cloud Storage. Billy Bob said something, put something in his object storage bucket. He sets the permissions to public, so anybody in the entire world can access it. And it kicks off an alert, and then an Azure function changes the permissions of what Billy Bob put in his storage account so that the company doesn't get hacked. That's called an event-driven. So Azure functions are designed to execute code in response to something else. Now, the reason people like this is you are not paying for a server to sit around and wait for it to go remediate something. But I want you to understand this. If you're remediating stuff all the time and you have constantly these functions are kicking off, it's going to get really expensive really fast, and it might be just as cheap to create the same event-driven architecture on a virtual machine. It might cost a lot less, so to keep that in mind. The point here is that the resources are not running continuously, so you're not thinking about patching the operating systems, what have you. So I kind of hope that makes sense. So what's good here, if you think it's good, is you can focus on the code versus the infrastructure. And if you're a software development firm and you've got 1 million software developers and very few of everybody else, this is great. And, in the world of AI writing our code for us, and yes, AI can write our code for us, and we're pretty soon to all of us being able to ask, please write me a program that does X, Y, Z thing. You can have an ordinary everyday person pop it into an Azure function, know nothing about the underlying technology, and it's going to work. So it's good there. It's also good for event-driven things like a REST request or a timer, a message from another service, anything that can be done quick. They scale automatically, meaning for the most part, you don't run out of capacity for these little functions. But if they're going to run, and they're going to run a lot, it's going to get prohibitively expensive, and you may want to look for something else. They are potentially cost efficient because you're only paying for the CPU time you're using, although you're paying a lot for it. But in the grand scheme of things, if you don't use it a lot and you have just sitting around waiting for somebody to do something silly and then respond to it, it is cheap and it is efficient. Now, we can go stateless or stateful with these Azure functions. Stateless is really the default, meaning everything happens brand new in response to event. So something occurs, there's no data stored, the next thing occurs. That is a stateless function. By comparison, a stateful function or a default function, which you can set up, will maintain the context across function calls. So this happens, and you'll be able to track and see what happened. So Azure functions, basically something happens and you use it in response to something else. That's typically why we would use them. They are very flexible. They are very adaptable and simple to use, and that's why people use them. So the next thing we're going to talk about is Azure hosting options. And obviously, we can put our applications on a virtual machine with ultimate control and ultimate flexibility. And that's one option. Option 2 is we put them on containers. Well, the next option is going to be the Azure App Service. And what's that really? What is that going to look like? Oops, I'm trying to draw a blank slide for me here. So we can use this. So this is an environment where you've got your developer. You've got this hosting service. And what happens is the developer takes their code, they host it, they upload it to the hosting service. And what happens that you can't see is the hosting service creates all the underlying infrastructure necessary, or has the infrastructure necessary to run the developer's code. So where's that going to run? It's going to run on servers. It's going to run on containers. It's going to run on. It's going to run on virtual machines. It's going to be in the same place, but you don't need to know about it. So all that underlying technology is under the hood. The developer uploads the code, and it just sort of works, assuming the cloud provider works. So Azure App Service is great for web apps or background jobs or mobile backends. You don't have to think about the infrastructure, which means you have no control of it, which is terrible. But if you don't know how to control it or how to manage it or how to maintain it, well, then that might be a good thing. Like, there's strengths and weaknesses of every approach. It scales automatically. So if you just put your code up there, you need more capacity, you get it. You need less capacity, you get it. So it sort of does it for you. And that's going to give you relatively decent performance. It supports all kinds of languages: .NET, .NET Core, Java, Ruby, Node.js, PHP, Python. And realistically speaking, you're given the flexibility of what operating system you need to run your application, whether that gets into Linux or Windows. And it integrates with GitHub, Azure DevOps, Git repositories for that continuous deployment type environment. So that's really what we're talking about. When we're dealing with it with regards to web apps, it's going to support almost anything you may want to use: ASP.NET, Core, Java, Ruby, Node.js, Python, any Windows, Linux operating system. It works with REST-based web APIs, so you can build your choice of language and framework. It's got full Swagger support if that's your thing. And we can go and you can package and publish various APIs to the Azure Marketplace to resell to others. We have the concept that we can do web jobs, which is like a background task, or run programs or scripts like a .exe, Java, that kind of thing running on something. We can schedule or trigger an event. And realistically speaking, that's what we're talking about Azure hosting options. We may use it for mobile apps. It gives us a very quick backend to set up. Ultimately, it's going to build the backend for an iOS or an Android app. It'll provide the storage, and it stores data in basically cloud-based SQL. It'll authenticate under whatever you want to authenticate against: Google, Twitter, Facebook, any kind of federated identity platform you want to use. We can send push notifications to users. Oh, by the way, there's this new thing on sale that you're interested in. We can run custom logic on it. And the real key is you're not managing the infrastructure. So it's easy. It takes less resources. They provide the security and the endpoints for the most part. And it provides a high availability environment with load balancing. So that's realistically what we're talking about. The next thing we'll get into, we're going to take a quick break, is going to be Azure Virtual Networking. But let's see what questions popped up. Mike, can you explain when is lift and shift migration valuable to a business? Please give a few use cases as you can. So, generally speaking, if your systems are housed in the data center and you've got good performance in your data center, lifting and shifting them to the cloud will reduce your performance and increase your costs. So, why are people doing lift and shifts? Well, I'll give you some industry examples of when it's good. The majority of these lift and shift applications were somebody from a cloud provider selling it, or in the early days of cloud computing, somebody got certified, they got excited, they thought they were going to save their company money, and they didn't understand the underlying infrastructure they were using or cloud billing, and realized how much more it was going to cost. So there is that. But when would you use lift and shift? So let's say, for example, the current environment you have is as follows. You've got a data center that has a lot of outages. You've got a lot of networking problems. You don't have the resources that know how to maintain the network. You can't find good people. So you go, you know what? Let me get the stuff off of my current environment. Let me shift it to the cloud. That could be one environment. And you're doing it because you no longer need as many sophisticated people. So there also could be a time where, let's say you've got a supply chain, let's say you're in manufacturing, and all your other people are already on the cloud, If you move certain systems to the cloud, you can take advantage of the cloud and simplify your networking to your extranet partners because they're already on the cloud. You're already on the cloud. You don't even need routers between you and them. In some cases, you could just use the cloud for private link type services. So that could be there. You may want to take something like a website. Let's say you've got a business and the business is growing and growing and growing and growing, and they've got unpredictable demand and they can't keep up with their website. Lift and shift that website to the cloud and add auto scaling. That makes sense. So there's that. But generally speaking, it's because you don't want to manage the infrastructure yourself, is why you would outsource your infrastructure. And that's realistically speaking, but which do you think is going to be cheaper? You buy an 5-bedroom home, and that costs you, say, $4,000 a month, or you rent a 5-bedroom suite in a hotel, and you pay $1,000 a day or $30,000 a month. That's what lift and shift really is in most locations. But if I've got a bad network, a bad data center, all my gear is dilapidated, and I don't have the money or the credit to go finance what I need, I might go to the cloud and rent it and be willing to pay a little more for it. So generally speaking, the lift and shift didn't make sense. The cloud providers, it was the way they could get systems on their business, but it's not really helping too many people too much. They'd probably be better off, hiring some good networking people. And you need good networking people or all the systems fall apart. Building their own data centers, financing or leasing their data center technology cost, and if they've got a good cost of capital, it'll typically be cheaper. How do they vet bring your own devices, such as for screen capture or shoulder surfing attacks? So it's not something I've been involved in, but generally speaking, the Azure has something called Microsoft Intune and Azure AD conditional access. And what that can do is they can actually look at your system and enforce security policy, like a screen capture restriction or an encryption on your device. For shoulder surfing, you can use Windows Information Protection, realistically speaking, but you can also mandate that people have like a privacy shield or something like that, or to the effect. The shoulder surfing one's a little bit harder. The screen capture one's a little bit easier. A lot of when it comes to security, realistically speaking, part of it is going to be user training. And that's going to be one of the bigger challenges that we have to plan as security architects. And I plan lots of security training. What kind of anti-phishing do we need? What kind of social engineering training do we have to do? Good question. We go to the next one, Chris. A virtual machine is just like a real computer. Can you connect your virtual machine to a private line? Well, technically, you may be able to, but you're not going to. So here's the thing, Freedom Lands. If I'm going to connect my computer to a cloud provider, I don't just need the connection to the cloud provider. I need to know how to reach all the subnets that I have in the cloud provider. So, how do I reach this subnet? How do I reach this subnet? How would I reach this part of the network, this part of the network? So, you're going to need with a private line to use BGP. So, if you've got the sophistication to take a Linux machine and you have the sophistication to install a routing daemon on it, and you have the sophistication to create and compile BGP code, and then put BGP on that physical computer, effectively you turn that computer into a router, then sure, you can connect that. But nobody's going to do this. They're going to buy a router and can terminate and use a router to connect that. So while it could be done, sure, I know people that work for routing companies that develop the routing code for routing companies that do create virtual routers and do it but for normal use, no, you have to connect your router to the private line. And you must run BGP when you use a private line to any cloud provider. Were there any others before we go back? All right, well, we'll get into virtual networking, and I love virtual networking. I always think it's fun. So we'll begin with, what is virtual networking? Well, we have physical networking. Physical networking is your routers, your switches, your cables, your optics. That is physical networking. But when you're on the cloud, all that stuff's done for you. You're not going to walk into the cloud providers and look at the routers and SSH into the routers and look at what other interior gateway protocol is. Are they using MPLS? Are they using traffic engineering? Are they running label distribution protocol or tag distribution protocol? Are they signaling L2 layer 2 tunnels with RSVP, for example? You're not going to see any of that, or you're not going to know any of it. So everything we deal with is going to be virtualized networking. In the data center, we need network engineers that know this to make this, because if that infrastructure doesn't work, you've got nothing. I mean nothing. And that's why your high availability people typically come from networking. But in Azure, you've got a virtual machine, and it's going to give you networking services. It can connect to the internet. Your virtual machines in one region can connect to another, because all the networking is being done for you by the cloud provider. So Azure virtual networking, we typically think of the VNet. And what is the VNet? The VNet is your virtual private data center where you're going to stick your stuff, your virtual machines, your databases, what have you. And because they're plugged into the network, and every virtual machine has a virtual network card in it, they will connect to the network. So we can connect our data center to the cloud, and the Azure VNet or virtual network will be an extension of our own data center that we have. Or it can be, if we're only in the cloud, that is our virtual private data center. The key here is your stuff is separated from everybody else's, and everything occurs via internet protocol. So what does that mean? And this is something for you to think about. In the data center, it is your data center, and you are the only users in the data center. But in the cloud, we have user A or company A. Okay. We've got company B over here. We've got company C. And we've got company D. Okay, so we don't want, under normal circumstances, anybody from company A to be able to reach company B. And company B shouldn't be able to reach company C, and C and D shouldn't talk to each other. And that's going to be the basis of how communications are. They are isolated. They are logically separated. Now, of course, if we want company A and company B to talk to each other, well, that's just easy. We create VNet or VPC peering based upon your cloud provider, and we can get them to talk to each other. But they are logically separated. That is why it's that virtual data center. You are separated from somebody else. So you got to need a network if you want anything to talk to each other. So you got a virtual machine here and a virtual machine here. They use your network. If you want your on-premise environment, your data center, connect to your cloud, no big deal. You can connect with it with, say, an IPsec tunnel like a VPN. You can connect to it with ExpressRoute. They don't talk about it in the Azure Solutions Architect Expert training because, it's still a relatively basic exam, but you could use a software-defined WAN. You can use a SASE type WAN to connect to these environments. If you're interested in learning about software-defined WANs or SASE WANs, my team, Chris, or somebody from my team can pop a link to some videos that me and Mark Milovanovich made on them. We also have some videos from Aviatrix on how the technology works as well. Again, that we made with Aviatrix. They're great at these kinds of things. In our virtual network, we will have a virtual router that will route traffic from subnet 1 to subnet 2 versus subnet 3, or out to the internet when we want it to. Inside of a virtual network, we can actually filter traffic with simple packet filters like a network security group. And we can connect virtual network to the virtual network with VPC peering, like I just showed you a minute ago. We will have private and public endpoints. And what is that? A private endpoint is going to be something inside of your network space. A public endpoint would be how do you reach something external to your environments, or we can create a public endpoint to be reachable from external environments. Inside of our VNet or our VPC or our virtual network, we will run private IP addressing. So that is the RFC 1918 address space, the 10.0.0.8/8, the 172.16.0.0/12, and we also have access to the 192.168.0.0/16. If you're brand new, remember we've got a subnetting workshop where we talk about subnetting and aggregation. My team can pop that link as well. And you're going to need to know BGP, so my team can pop a link to that as well. So there you've got some things to help you with networking. Now, we could also use what's called a public IP address or a globally routable IP address, which we can put on a load balancer or something that we want to be reachable from the internet. And we will use Azure Virtual Networking to connect to everything, virtual machines, containers, what have you. We can you connect to a certain endpoint like an Azure database. So that's that. We can also create connectivity. So realistically speaking, there's two kinds of connectivity that we can talk about, or a couple kinds. We can talk about a point-to-site VPN, a site-to-site VPN, and we'll talk about a private lines. And of course, when we use this, we can automatically route traffic back and forth between our environments with Azure networking. We have the ability to create a route table or where our traffic goes. And of course, we can use routing protocols like BGP. So let's talk about the difference between a point-to-point VPN, a site-to-site VPN, and the Azure Express route. So let me draw this out for you as a reminder. So here's a point-to-site. In a point-to-site, let's say we have the data center. And then, of course, we have to have the user of the technology of that data center itself. So in this particular environment, we have a user. That user wants to VPN to work. So the user sits over here. They have a PC. Their PC has a VPN client. Here we have the lovely Cindy. Oops, I don't know what happened there. And the lovely Cindy wants to go to work for the day. So she VPNs into our data center. She gets an IP address back from the data center, and she's off at working. She's happy. So that is a point-to-site VPN. Now, a site-to-site VPN is going to be different. And it can be a data center. So let's say we've got a data center, and let's say this is in New York. We've got a data center in, say, London. And we create an IPsec tunnel between them. Now, so if we do this, every user, let's say this is a campus/data center. So if we've got 5,000 users here, and in London, we've got 5,000 users here, then all 5,000 users in London can reach any of the 5,000 systems we actually have in the data center with our site-to-site VPN. Now, if this is not a physical data center, and this is your Azure VNet, and this is your competitor's Azure VNet, or this is a partner Azure VNet, we could create a site-to-site VPN between them if we wanted to, going through the internet, or we could actually do VNet peering. But the concept is, realistically speaking, the same. It's still a VPN. It's just, is it a VPN over the public internet, or are we creating a VPN across the Azure backbone, or are we going to use VPC peering, which effectively is them doing something very similar for you in an automatic environment? And because I know we covered it last week, but just in case, because most people don't understand how these private lines work, they're very simple, and this is the way an AWS direct connection is going to work. It's the way ExpressRoute is going to work. So we've got our campus. Sorry about my sniffles. That cat slept on my head last night, and I've been having allergies ever since, and nothing seems to make it better. So on our campus, we're gonna have a router here, and what we do is we connect to an environment like this. And what we're really doing here is we've got our device. It's typically going to be called the customer edge device. and this is going to be like a router or a switch. And we will buy a connection from point A to point B, which is the router to the customer edge device. And there will be what's called the provider edge router, and this router will be owned by Azure or AWS, depending upon the cloud provider. And then here's your cloud provider. Cloud provider data center. So what they will have is they will have a big, thick, or multiple big, thick links that connect them from this router, their provider edge router in this location, to their environment. This transit from their router back to the cloud is typically called backhaul. So what you will do is you will buy this link from you to that direct connection location, that express route location, and you will need to get a letter, which is permission for the data center, this environment, to run a cable between your customer edge device, what you own, and the provider edge device, which they own. This is called a cross connect. But that's realistically works and how these express route connections work. Same thing on all providers. So understand that. Now, in a data center, you have a router, and you could put a packet filter on a router called an access control list. On the cloud provider, when you're on the systems, you're using virtual routers. And what do virtual routers have? They have some form of a packet filter like an access control list, but Azure calls them network security groups. And it's a packet filter. Allow TCP port whatever to connect to server with the address of 2.3.4.5 on port 443 for basically letting HTTPS traffic in. Like a firewall, but it has less features and functionalities than an enterprise-grade next-generation firewall. But that's realistically speaking what we're talking about. So we can run them on the cloud. And we can also use, network virtual appliances. So if we need security, we're not going to use an AWS firewall. We're not going to use an Azure firewall if we need enterprise-grade security as a rule. We're going to go to one of the marketplaces, and we'll get a router from, say, Palo Alto or Cisco or Checkpoint. It's going to run on a virtual machine, and that's where we can create some very good security with firewalls that are adaptive in nature. So we can do that too inside of a virtual network. Now we can also connect our virtual networks. I showed you how we can connect them a few minutes ago with VPC peering. And what it's going to do is basically create a private network over the Azure network as opposed to the internet. We can also define user-defined routes and create custom routing tables to determine how traffic will go from one place to another place. Now let's talk about Azure VPNs. There's a lot of different VPN technology. In fact, anytime you make a private network over a public network, it's called VPN. So the frame relay circuits of the early 90s, that was technically a layer 2 VPN. The ATM circuits, that was a layer 2 VPN. VPLS, where you buy a link, which is a private line or a virtual wire over an IP network, is actually a VPN. But typically when we talk about VPNs, we're talking about IPsec tunnels. So that's what we're going to talk about here. And we could create an IPsec tunnel, which is a protocol to tunnel the internet protocol over a public network in a secure environment. We talked about that quite a bit last week, if you need to refresh on how the VPNs work. And the way these work is you need to have something connect to something else. So we can create that site-to-site environment like I showed you earlier, that point-to-site environment, or the network-to-network. But you got to remember here is we are creating an environment. We are creating some degree of security. So if we go to this environment, if we had, say, two sets of users, if we had user over here, so let's say this user is Cindy. She's that cute little girl that I had showed you before. And Cindy, Chris has a really cute cat called Sunny. It's a Maine Coon. It's orange. It's beautiful. It's huge too. So let's say Cindy and Sunny are friends, and they want to plot. They're plotting about how they can start some new e-commerce business of fancy cat stuff, and they're going to have the internet between them. But the point here is that they're going to take the IP packets which is our data. Basically speaking, we're going to encapsulate or put that packet inside of another packet, which is an IPsec packet. And by doing it, all this data from point A to point B will be secured. And what will happen along the way to make this happen is this will be encrypted along the way, and Cindy and Sunny will agree on the type of encryption. They will agree on the type of encryption key they send along the way. They will hash their data to make sure the data hasn't been changed along the way. And they will sequence their data, message 1, message 2, message 3. And why are we doing this? Well, the whole point is if we've got the internet looking like this, bear with me, trying to find my cloud here and my Microsoft symbols while we're live. Let's see. Oh, here we go. So the internet has always been considered a cloud. And why is the internet a cloud? Because typically speaking, you don't know. So what happens is we have our message that goes through the cloud. Nobody can see it because it's encrypted, which means because it's encrypted, and we're using encryption, Cindy and Sunny can authenticate each other and make sure Cindy is Cindy and Sunny is Sunny. Because, they're building this multi-billion-dollar cat food business empire together, and they want to make sure nobody gets access to their information. So encryption will determine who they are, preventing a man-in-the-middle attack. Encryption, we're going to encrypt the entire packet, including the header, so nobody will be able to see that Cindy is talking to Sunny. Unlike SSL or TLS-based encryption, where it encrypts the payload but not the headers, with TLS encryption, you would know that Cindy and Sunny are talking to each other. You just wouldn't know what. In IPsec encryption, you can't even tell that the two of them are talking to each other. The data will be hashed so that if Cindy sends a message to Sunny, Sunny knows it hasn't been changed, and that will be sequenced. So Cindy can't say later to Sunny, I didn't say that. What are you talking about? That's called non-repudiation. So why might we use a virtual network? Well, maybe we've got to transfer data. Or maybe we just need to connect two entities over a distance. And each virtual network, meaning your VNet, will have one VPN gateway. But that VPN gateway is effectively a virtual router terminating your VPN, so it can connect to a lot of different environments. Hope that makes sense. So we can create a policy-based VPN where we can basically send the traffic to a certain place. We can specifically statically define the addresses of the packets that we wanted to be encrypted if we wanted. And then we can evaluate every packet against the addresses that are allowed in the tunnel or not allowed in the tunnel to further enhance our security. We might use it to connect virtual networks. We might use it to connect multiple locations. So there's that. We can also basically use it and commingle this with an Azure Express Route Gateway, which is going to be there. So why might we do this? Let's say we have a private line or an express route as our primary. We might have a VPN as a backup in case the private line goes down. Or we may have a private line backing up a private line. And that's going to depend upon the criticality of the network needs for the organization. And the organization will evaluate all trade-offs, cost, what have you, to determine what they need, architectural challenges of each. Now, I mentioned that these VPNs are typically, they call them high availability, because what ultimately happens is it automatically creates two instances on the cloud provider. So if one system doesn't work, the other one does. It'll just fail over the other virtual VPN gateway, which is great. And if there's an issue, it gets taken down for maintenance, they're typically coming up pretty quickly. But we have to remember, we still have a single point of failure, even though they say it's high availability. And that's where people go wrong, is they just assume it's high availability, but it's not. Here's the thing. Even if you have this virtual device, and this virtual device has a virtual device here, and another, you connect to the virtual device, and the virtual device moves around and connects you to two different environments. But you still have to remember this. You're coming from here. So if your goal is to create a tunnel between this router that you have and this virtual device, which could really be one of two different virtual devices, because that's what's really going on, a primary and a backup VPN, so call it a virtual router, if you will. And that it could sit here, it could sit here. If this goes down, we've got no problem. If this goes down and the other one's up, you've got no problem. This virtual router on the cloud provider side, not going to go down in case the whole cloud goes down because it's not physical, it's logical. Here's your problem. Your internet connection between your virtual router, between your location and your virtual router goes down, you've got nothing. Zaba, Deepata, Bupkis, depending upon what part of the world you're in. Nothing. If this router over here that you're using for your VPN goes down, you got nothing. So this looks good in theory. So if you're going to use this, make sure you have more than one router in your data center connecting to the cloud provider, and make sure you have more than one internet service provider. Otherwise, your backup is nothing. Or your primary VPN could be nothing. So we can create an active environment where we've got two VPNs at the same time. And basically, we're going to have a different IP to each instance, and we're going to have two separate tunnels. We can do that. We can do an express route failover. Primary route goes through the private line, the express route. Backup routes go through the VPN for additional resiliencies. And we've got we can do zone redundant gateways. So we can configure a VPN gateway as an alternative if our express route goes down. We always have multiple options, but we always have to think about most sides of the equation. Now, I kind of went into what an express route was, but here's the thing. An express route is the modern version of a private line. The internet is not guaranteed. So the internet traffic could be great. It could be horrible. There's no guarantee when I use the internet that my traffic will ever get anywhere other than to the ISP that I'm connected to. So if it matters, if you need high performance, guaranteed bandwidth, you use a private line, express route, direct connect, direct interconnect, whatever the cloud provider's marketing team wants to call it. Guaranteed performance. You buy 10 gigs to the cloud provider, you get 10 gigs minus whatever your Ethernet overheads are and your IP overheads. But it's always there. Latency doesn't change with the internet. You could have 2 milliseconds of latency now and 20 milliseconds a second from now. No guarantees. So if you need good performance, you must use a private line, and it's been that way for decades. You can get closer to private line type performance with software-defined networking and like an SD-WAN or a SASE, but still nothing quite now equals the real thing, which is the private line. It is a private wire, effectively, between you and them. And I drew that out for you a few minutes ago. Over your private line, you can also connect to other Microsoft services that are parts of the Microsoft cloud, even things like Microsoft 365, in addition to Azure. It gives you a great performance, and it's going to provide direct wire-like, because it's basically you're buying a wire between you and Azure. So access to everything. Global connectivity, because you can get a circuit or a private line between you and the cloud provider, and then that can reach anything on the cloud provider. Or you could get a circuit to a region in the US, a circuit to a region in the UK, a region to a circuit in Asia, and that way, if any of your private lines go down, you've got a backup private line. So you can do anything you want. And this is the domain where network architects like me and Mark Milovanovich from our team, we actually live. When you use ExpressRoute, you must use .ubgp to exchange routes, meaning a routing product on Exterior Gateway Protocol. And that way, whatever routes you have in your data center, the ones you choose to send to the cloud provider will be reachable from the cloud provider. As you add different subnets in the cloud provider and you advertise them into BGP, they will become reachable from your data center. So, dynamic routing. The more routes and the more reachability we have, it makes it easier for high availability. We can configure multiple circuits if we want. And realistically speaking, that's what we're dealing with. It's a point-to-point Ethernet connection between you and the cloud. Because we're connecting a wide area network to Azure, it's going to be the same kind of wide area network that we could use to create an any network to any network kind of connection like we've done for the last 40 years. We can connect via high performance networking. We can create up to dual 100 gig links to the cloud provider, or 10 gig links, or single links. We can go active, which means we have two links and we're sending data on both links. We can go active standby, which is this link is active and this link is doing nothing until this link goes down. Well, if you feel like paying for a link and doing nothing with it, you can do that. But if, and only if, we're going to have an active link and an active link across two wide area networks running BGP, you must know BGP and you must know how to load share without getting out of order packets, or you will run into a world to hurt. The level of sophistication knowledge for BGP is moderate. And something junior level networking wise, like the AWS Advanced Networking, they'll tell you just block a link and you don't have to worry about it. In the world I come from, with people that need to know networking, or we're network architects, we're designing and planning the internet, that would never suffice. So there's a great video that Mark and I did. It was 6 or 7 hours, and we talked about how to traffic engineer and load share across direct connections. My team will pop that in the chat box for you. Here's the thing. If you use a private line, your traffic is not going over the internet. So it's more secure. That doesn't necessarily mitigate the need to run IPsec or some other form of encryption over your link, because the reality is nobody can get access to your link unless they can break into the direct connection of the facility, or create a tap in the fiber, which is buried under the ground, because it's a private wire between you and them. But you may want to do it anyway. At Cisco, we started running IPsec over private lines back in 1998. The cloud providers are about the point where they enable you to do them now. So keep that in the back of mind. The next thing we need to cover is actually DNS. Chris, how long has it been since our last question break? Okay, maybe I'll take questions before I get into DNS real quick. Can you use bidirectional forwarding between a firewall and the corporate data center and the direct express connection? So typically speaking, between your router connected to the direct connect location and direct location, you may want to use bidirectional link forwarding, which realistically means you've got a send and receive laser. And if one goes down, like the send laser, and your receive laser is still up, your link won't go down and the routing protocol won't notice that it's there. Generally speaking, the firewalls don't support bilateral forwarding detection, but a switch does. So it's going to be dependent upon a lot of factors there, Mohammed. But that's really going to be the thing that really matters. So IPsec over VXLAN is going to be completely different than a site-to-site. So VXLAN, realistically speaking, and it's not something I've actually worked with, because I started moving into executive architect roles prior to that coming out. But VXLAN is more of a means to control large amounts of VLANs inside of a data center and using BGP to actually carry that VLAN type information. So what we're actually talking about here is going to be a little different. And so it's going to be different because it's generally speaking in your facility versus something that's there. So site-to-site VPNs are going to use IPsec, but we could actually do IPsec over XVLAN potentially in a data center. We might be able to do it for network segmentation, realistically speaking, but site-to-site VPN, one network to another. VXLAN is more for carrying layer 2 information through BGP. I think we go to the next one. Hi, Mike. If I were to build a hybrid cloud solution where I'm using ExpressRoute as the primary and S2S as the secondary, well, I'm not really sure what you mean by S2S. It may mean site to site, but it may mean something different. So I am not 100% sure. You can use BGP, but generally speaking, if you're talking about a site to site VPN and you've got a private line, you could use BGP on both. And what you would typically do is for the subnets that you want to go over the private line, you would typically either lower the weight or lower the preference, or and what you might actually do on the VPN, you might prepend the autonomous system numbers to make it look less unfavorable. You could potentially spend a more specific subnets over the one over your primary link and aggregate routes on your VPN to prioritize your traffic and differentiate it. So that could also be done as well. But yeah, you would definitely use BGP, or because if you don't use BGP, then you need to actually create static routes. And if you're going to create static routes, what'll happen is the static route will have what's called a lower administrative distance in a Cisco router, and static routes are generally preferred over dynamically learned routes. So if you were going to use a static route, you would have for the VPN, you would have to do something to manipulate it to make it less preferable, either via making it a more aggregate route or a less specific subnet, or changing the administrative distance or the equivalent based upon your routers, that kind of thing. But yes, you can do it, assuming you mean site to site. Good question there. Any others? Otherwise, we're going to get into DNS. How ExpressRoute deal with a partner whose connection is linked to a customer? So I don't honestly understand the question. But I mean, you and many other companies are going to have isolated express routes, meaning express route from customer A won't be able to be there from express route customer B. Now, you could potentially be dealing, I have an express route to my VPC, and my VPC has VNet, a VPC VNet has VNet peering to other things. And if you put that information into BGP and you advertise that information back down, you could potentially use your private line or your express route to go from your data center to the cloud, and then use that as a cloud wide area network to connect to different VNets or different companies. You could do that. I'm not sure which one of those scenarios you were actually referring to, but either one could work. I don't understand the next one, which is the equivalent. So I'm going to get back to the content now. So let's talk about DNS. And I am not a sysadmin, and sysadmins are the people that typically deal with DSS, not really architects. But I'm going to cover our DNS and talk about how we would use it, where we would use it, why we'd use it, and the point, according to the way Azure wants you to know it. So there's a couple types of DNS that we have with Azure. I'm going to start with Azure DNS. Azure DNS is a very basic, very simple hosting service that provides name resolution for things on your Azure infrastructure. So it maps a name to an IP address. And we can use it to basically have a application server that connects to a DNS address of a database. And if we make the DNS address db1.whatever.com or .net or what have you, that fully qualified domain name, the DNS will resolve between the application servers and the database. Now we used to do this, have your application server directly mapped to the IP address of the database server. But realistically speaking, here's why we use DNS. If all of a sudden I need a new IP, I need a new server, it's going to come up and it's going to get a new IP address. And the application server is designed to point to a DNS name. So we could just potentially update the DNS records to match to the new to the new IP address of the database servers. And that way we don't have to recode our applications every time. The other reason we're dealing with DNS is it's a whole lot easier to remember www.cisco.com than it actually is the IP address of cisco.com. Unless you're my wife who can learn Spanish in 10 days, and she did, and can remember things from 25 years ago, including what I said on our second date, which is both great and bad. The rest of us need something to remember. And Cisco.com or Amazon.com or Microsoft.com is easier than an IP address. So that's why we're using DNS. Well, we deal with Azure DNS. It uses something called Anycast. And Anycast gives us access to the closest available servers. So I'm going to briefly drive a little bit of point home on Anycast because that's something that confuses most people. So here's our internet. And this is the internet. And now we have a DNS server. I'm just going to use 8.8.8.8 because that's Google's DNS servers. And they're also Anycast. And because I think it'll make life a little easier than me picking some random IP address that might actually be used. But it all works the same way. And the way Anycast works is as follows. You actually have multiple DNS servers with the same publicly facing IP address. Ugh, that sounds ugly, right? Well, it is and it isn't. So here we have the user over here. We've got user A. And user A is sitting in Florida. This DNS server is near Florida. So user A goes to his ISP. His ISP says, oh, 8.8.8, go here. And by doing so, the DNS server, let's pretend it's in Florida. User A is in Florida, gets really, really great speed and performance. And because even though these servers are all synchronized with the same information, so the same information on this DNS server is on this DNS server. And that's one of the things that's necessary to make Anycast work. Now, all of a sudden, this server crashes. The DNS server in Florida crashes. And my computer goes to the internet. And the ISP says, yes, I still have a route to 8.8.8.8, your DNS servers. And maybe this is in San Francisco versus Florida. It doesn't matter. All my PC needs to know is to go to 8.8.8. So when we deal with high availability DNS, and there's other times in IP multicast, we use Anycast as well. Anycast is two servers with the same IP address, and you reach the one that's closest to you from your routing protocol, and it goes down, you can reach the next one. So Azure supports Anycast. Now when you use Azure DNS, it's got some security features. It's based on the Azure Resource Manager, which means we can set up a role-based access control, meaning these people can access the DNS servers, but not others. When we work with Azure DNS, it will create an activity log so we know who did what. And it's got the concept of a resource lock, so that enables Cindy the cat, who walks on my keyboard, not to accidentally delete the DNS information. So all good stuff there. Azure DNS is very easy to use. It manages the DNS records of Azure services and external services. You typically use it for a simple website like a type A record, meaning to connect to 1.2.3.4, connect to www.something.com. Very simple. It'll work with private DNS domains, custom DNS domains. We can manage these domains and records with the Azure portal, the PowerShell commands, the Azure CLI, what have you. It's really about, we can create alias records with it. Realistically speaking, what we're dealing with, maybe the public IP address of a traffic manager profile or a content delivery network endpoint. Here's the key. It's very simple DNS that works. It uses Anycast for high availability. It's very easy to manage for those that are familiar with Azure and Azure tools. It can provide custom DNS names for your private virtual networks as well as publicly. And it enables you to create an alias record set. At some point, we'll actually get into Traffic Manager as well. But with the Azure DNS, you can purchase your DNS, but it doesn't support DNS purchase, domain name purchases directly. So domains can be purchased using app service domains or third-party registrars like GoDaddy, for example, or Bluehost as another DNS provider. Ionis is another DNS provider. It has lots of them. But once you purchase your name from a DSR registrar, you can host it in Azure. And we'll get more into these concepts as we progress through the training. Now, we're briefly going to discuss storage. So what's storage? It's where you store your data. So there's lots of different options for storage in cloud computing, and we'll go through them. We did a lot more storage last week, but we'll go through them. So we're going to begin with Azure storage accounts. And as an overview, it's going to be, that's in a unique namespace for your Azure data. And when you create an Azure storage account, your data is going to be accessible anywhere over HTTP or HTTPS. Don't use HTTP, use HTTPS. When your data is in Azure, it tends to be secure. It tends to be highly available, meaning it's there when you need it. And it tends to be durable, which means even if it's not available when you need it, it's not going anywhere. It's typically well backed up. And one thing to remember on cloud with cloud-based storage is it's very scalable. The cloud providers just purchase assuming you're going to come. So generally speaking, you don't run out of capacity. We can create various types of storage accounts, and we'll determine the type of storage services we need based upon how much redundancy, what do we need for our business, that kind of thing. Because the type of storage account we choose will determine what we can do with the storage and what's going to fit into what parts of our architecture. From a redundancy option, meaning, how many failures you can tolerate and still access your stuff, we have the concept of locally redundant storage. And what that is you take your data and it's copied asynchronously 3 times within the single physical location. So I have my data here, and it might be copied to 3 different RAID arrays inside the same data center. Okay, well, this is going to be good to prevent against hardware failure. Maybe a RAID array goes bad. But now you got a disaster, like an earthquake or a hurricane. And poof, everything's down all at the same time. So definitely you're going to be a cheaper option, but not going to be something that's going to be great from a system resiliency perspective or a high availability perspective, because locally. We can also do something called the geo-redundant storage. And that's going to take and copy your data 3 times within a physical location and then copy it to another location in a different region. So you got a disaster, and it only affects the US, but it's copied to Europe, and there's no routing, there's no control plane failures, there's no hacking events, and your system is still there. So that's a better option. Of course, we could store in 2 clouds and not have any of these things to worry about. We can also set up something called read access geo-redundant storage. And that's going to give us the same redundancy as what we just talked about, the zone redundant storage. Actually, so it's going to give us the same redundancy as the geo-redundant storage, but it's going to provide read-only access to the data in the secondary location. So full read-write control primarily, and only read. So that means the data in the backup location, nobody can write to it at all. So we'd have to get that data, pull it, and change the permissions on it, which is something to think about, potentially for security purposes. And of course, we have zone redundant storage, which I talked about, which is going to copy your data across 3 Azure availability zones in the primary region. So that's going to give us some good local redundancy, meaning something happens to one data center, chances are the other data centers are probably still okay, unless there's the control plane event, a security event, or a major network outage, because you won't be able to reach it then. So we're going to discuss storage endpoints, and here's the thing: for certain things, you need to connect to something. When you terminate a VPN, you connect to the VPN termination device. When a phone company would give you a serial line or a private line, they put this CSU, DSU, which is where they terminated the connection in there, and then you plugged your router into it. So we always need something to connect to it. Connect to something, in many cases, is a virtual device called an endpoint. And Azure has storage account endpoints, which is the way you enable things. No different than connecting the gateway endpoint in AWS to, say, S3. We're dealing with endpoints in Azure to connect to storage things. So keep that in the back of your mind. One thing that's kind of cool is we get a unique namespace for our data. So it's one of the primary benefits. Be giving us a DNS namespace type account for that. And every storage account will have a unique Azure name, a namespace. We can, if we want to form an endpoint, it's going to be a combination of the account name and the Azure service endpoint, which is going to form the endpoint for your storage account. And with regards to endpoints used, these endpoints will be used to access various services. So blog storage, table, queue storage, file storage inside of your storage account, because that's the thing that's terminating that we're actually connecting to. Now, when we name our systems, we have some things that we need to do. So we can name our storage accounts with any letters between 3 and 24 characters in length. Names may contain letters and numbers and lowercase letters only, and they need to be globally unique. So your storage account name must be unique within Azure. No two storage accounts can have the same name. And the point of this is to have a unique address space. So kind of like a DNS address. We're not going to have two addresses with the same thing, generally speaking. So that kind of thing. And I'll give you some examples of what things look like. I'll pop them in the chat box. For example, here's what a blob storage endpoint might be named. Hopefully I can paste this into the chat box. That's an example of a blob endpoint name. We may have a table storage endpoint, which I can pop in the chat box. You can see, so you can see what that looks like. And obviously, this would be the format of how you would name it. So now let's talk about the various forms of storage endpoints. And we have blob storage, which is going to be object storage. And that's going to be very scalable for text and binary data. We will have support for big data analytics through Data Lake Storage Gen 2. We have Azure File Storage, which is basically file shares, meaning a file server, like if you had multiple systems that needed to share the same resources, whether it be an NFS type share for Linux systems or a server message block share for Windows systems. We have Azure Queues, meaning a messaging store for reliable messaging between components. We have Azure Disks, which will be block level storage for Azure volumes. And we also have Azure Tables, which is going to be like a no SQL table for structured non-relational data, or semi-structured anyway. Azure Tables are really designed for large amounts of structured data, and it uses a no SQL data store for non-relational data. So some key things to think about with regards to Azure storage: it tends to be redundant. And what does that mean? It means if you've got a problem with one part of your network, it's going to be redundant. Like one thing goes down, you got another one. So it's going to protect you against the basic hardware fire. And you have lots of options to replicate your data across data centers or even regions for additional protection. Generally speaking, your data is secure when it's written to Azure, because unless Azure gets hacked, your systems are going to be there. Does Azure get hacked? Sure. Do cloud providers get hacked? Sure. But generally speaking, they've got good security, and they're very good at running their systems. And when you're a cloud provider, you're one of the highest value targets in the world. Get into the cloud provider, you get access to everybody. So people are constantly working on attacking these cloud providers because they're the biggest, highest value targets in the world, or some of them. Azure storage scales because they've got lots of capacity. And here's the thing: if you've got a data center and storage, let's say you've got a RAID array, or you've got your storage area networks, their systems themselves. In the data center, you may actually have to patch the operating systems on your network storage. On the cloud, they do it for you. So in many cases, it's managed and it's easier. They manage updates, hardware maintenance, critical issues. They've got a hard drive that fails in the RAID array. They pop it in, they rebuild the data, that kind of thing. That's what they do. Now, with Azure Storage accounts, you can access your data over HTTP or HTTPS. Don't use HTTP plain text for your data. Use HTTPS. You can use client libraries that are going to be available in various languages and a mature, say REST API. You can run scripts in Azure PowerShell, for example, or Azure CLI. And your storage is going to be relatively easy to manage through the Azure portal or the Azure Storage Explorer. So let's talk about blobs, object storage. Azure blobs are just an object storage solution for unstructured data. Same as AWS S3, same as Google Cloud Storage, same as the same object storage we've been using in the data center for the last 30 years. Now, massive amounts of text, massive amounts of binary data. It's ideal for images, documents, video files, photo files, log files, that kind of thing. It's accessible globally. You can reach it. And you can use URLs, REST APIs, PowerShell. Now, when it comes to blob storage, we have multiple access tiers. We talked a lot more about this from a techie perspective last week, so we're going to talk more about it now. Where would you use it? We've got the hot access tier, and that's for stuff you're going to use every day. It's going to be the most expensive to store, but you don't have to pay for the most part anything to access it. Lowest cost. Then we have the cool tier, and that's kind of the equivalent of AWS S3 and frequent access. It's for infrequently accessed data that's going to be stored for at least 30 days. We're going to pay to retrieve it, so to speak, but we're going to pay less to store it there. We're going to have the cold tier, and that's for data that's going to be stored for at least 90 days. Again, pay a retrieval fee to put it there, but it's going to be cheaper to store it there. And then we've got this concept for an archive tier, and that's for rarely accessed data. Data that we're going to store for at least 180 days. We want flexibility, latency requirements, but for that benefit of having all that, we get lower cost. Now we're going to talk about the Azure file storage. File storage is when you've got storage that need to be accessed by multiple systems at the same time. So over here, we've got file storage. And this is typically a server, like a file server. It could also be file storage, which is basically a managed file server for you, whatever you want. I don't care. And then we've got a server and another server. And all these systems have to access this same information from the same file store. And that's when we use file storage. So when we're dealing with file storage protocols, it's NFS for Linux. It's Server Message Blocker SMB for Windows. This is where you take a drive and you map the drive to your computer. Same kind of thing. And it's basically file storage. So you can build your own file server, share a drive, or you can use this Azure managed file storage, whatever you feel like. It's the same concept. They manage those servers for you. It's fully managed. So if you deal with Azure storage services, specifically Azure File, you don't have to manage the file service and the storage spaces that you would have in your server. It supports any kind of scripting that you might want to use, whether it be PowerShell, the Azure CLI, or the Azure portal. It's fairly resilient, and it's built for high availability because these are managed file servers that you're dealing with. And it's going to be familiar for programmability because it's file servers. So you'll be able to access the file system over an IO API or an Azure Storage Client Library. So that's file storage. Next type of storage is Azure queues. Remember last week when we talked about scaling a database and we talked about placing a queue between your application server and your database server? And we talked about how you may have a messaging system or any kind of distributed application where you want to decouple it and take messages from one place, store it somewhere until the receiving end's able to do it. That's what we're talking about with regards to Azure Queue. And it's a service for securing large number of messages. We would use it to create a backlog of work to process asynchronously, like all the orders in a database before the database can handle writing these orders, because if the database is busy, it don't work. So that's a type of storage. We can also use Azure Disks. What is an Azure Disk? It is a block level storage environment we potentially have for our actual environment. So I kind of hope that makes sense. Now I'm going to we'll talk a little bit about Azure data migration options. Or actually, before I do that, let me go check in with anybody and see if there were any quick questions that popped up. Maybe do 5 minutes of questions here. For ExpressRoute, what is the equivalent to a hosted connection at AWS? So I'm not sure what you mean by hosted connection, but I will tell you the equivalent is a what do you call it? A direct connect, which you're actually talking about. So you may also be talking about an AWS hosted connection, like a partner circuit, if that's what you're talking about. And if so, that would be an ExpressRoute partner circuit. But are you referring to a direct connection partner where basically you go to somebody else and they give you a tiered lower pace than if you just went to the providers themselves? I'm not really sure what you actually mean here. Is there a control plane used in data centers? Absolutely. Data centers will have a tremendous number of control planes. So let's talk about it. In a modern data center, which is any data center, say after 1999, you will typically have your data centers virtualized just like any other cloud provider. So you may have VMware vSphere. And basically, VMware vSphere says, I go to VMware, and I've got an application in a portal. I want to create a server. I tell it that I need 18 cores and 50 gigs of DRAM and this type of hard drive. And the VMware vSphere will look at all the servers it has. It looks where it will have capacity, and it'll put it there. In the modern world, we are either using VMware, and it's not going anywhere in enterprise scale global computing, but there's some really good competitors, specifically Nutanix, which is a private cloud, which provides control plane services, just like that VMware environment I'm doing. And also, we also have the, what else am I talking about? We could have OpenStack as another cloud. So always we have a control plane that is dealing with our, our actual virtual machines. We may also have a control plane for dealing with our various storage area networks. Now, our routers and switches will need to determine how do you get your network traffic through that. And that means you're going to be dealing with interior gateway routing protocols such as OSPF or IS-IS or EIGRP based upon the data center that's being used internally. And of course, they're going to be using BGP connected, and all of that stuff is considered control plane. In the data center, we will typically have containers just like we have on the cloud, which means data centers are also going to be running a Kubernetes control plane on top of their virtualization control plane, maybe in the form of IBM OpenShift, or they manage their own Kubernetes clusters. So yes, data centers have a tremendous amount of control planes. And if you actually look at a modern data center that's used by an enterprise, and you look at a data center that's made by the cloud provider, you know what you're going to notice? It's the same. And they've been this way for decades. The only difference is the cloud providers are often bigger. But I've worked with clients that have a $2 billion a year technology spend on average. So their data centers look like cloud providers. So yes, data centers definitely have control planes. And the control plane is that management and orchestration plane. Sure, we have data centers and we have switches that are connected by fibers and optics, but something has to manage that. Because just because we had connections doesn't mean two devices could talk to each other. We need to get the routing so things can talk to each other. That's a great question, I think. Okay, no more. Wow. Now we'll get back to the concept. So I'd like to know that you're awake, alert, and oriented. If you're having a good time and you're learning something, please give this video a like, subscribe to the channel, hit the bell to be notified of new videos. In the description of this video, and most of our videos, there are a lot of options to help you with your career. Free resources on becoming a cloud architect, free webinars like the one we're going to have on Thursday on how to get your first cloud job. Sign up. It's free. It'll be on Zoom. We're happy to answer any questions you have. Free resources on interviews. So many free resources, and they're all free. So go get them. We want to do everything we can. So now we're going to briefly discuss some Azure data migration options. So a couple ways we can migrate our data. And yes, if you're here and you're awake, alert, and oriented, give me a hashtag Azure Solutions Architect Expert or a hashtag AZ305, some way that we know that you're. So the first data migration option we're going to talk about is Azure Migrate. And that is really a service to help you migrate from your on-premises environments to your cloud. And what it's going to do is it's going to perform an assessment of your information, and it provides a migration platform with a single portal for starting, running, and tracking your migrations. It comes with a wide variety of tools. It can discover and assess your on-premises virtual machines, so your VMware systems and their virtual machines, your Windows Hyper-V systems, your physical servers. And that way, it can help you move them over. It can also help with server migration because it'll migrate all these virtual machines, VMware virtual machines, Hyper-Vs, physical servers, and other things into something that would be more native to run in Azure. There's other tools as well. There's the discovery and assessment. And there's also some data migration things, tools to assess your SQL servers. And these typically identify potential problems blocking your migrations, or maybe you're using unsupported features, and you need to switch over to some new feature. It kind of gives you the right path. Or, of course, you can just copy your virtual machine over to the cloud and run it directly in the cloud with, creating a machine images of it. There's a database migration service, which can help you migrate from your on-premise databases to these Azure proprietary databases, which I don't recommend you use, given that 98% of organizations are multi-cloud. And if you get into any of these proprietary things, that might not be your best option. We also have the Azure App Service Migration Assistant, which is going to be a standalone tool to assess websites and figure out what's necessary to manage them to the Azure App Surface. And this is, for example, if you wanted to migrate a .NET or PHP type website to Azure. And Azure migration also integrates with standard, in ISV tools. So what do I mean? Independent software vendor offering. So it works with lots of different environments. Now, remember, if we've got a direct connection or a VPN to the cloud, we can push our information over the network. And the bigger the network connections we have, the faster we can get them there. But that may not always be optional. So sometimes we may want to copy our information to a device, ship that device to Azure if we don't have the network. So I'm going to begin with the Azure Data Box. And the Azure Data Box is a physical server. It typically comes to you. It's a ruggedized computer. It's got high-speed networking. It gets shipped to you. They typically cover about 80 terabytes, so it's a moderate amount of storage. Not a crazy amount of storage, but a moderate amount of storage. You order the device, it comes, you plug it into the network, you upload your data to the device, and then you ship it back to Azure, and they put it in object storage, and then you pull it off. That's your typical data box. We might use these if we don't have a high-speed connection. We might use it for a one-time migration to migrate a lot amount of data. Maybe we need 10 data boxes for 800 terabytes. Maybe we want to move a media library from some offline tapes to Azure for online access. Maybe we want to migrate some servers and we copy them into an image and copy that image to the cloud. Maybe we've got a lot of data we've been capturing forever and we want to move it to Azure because they've got some great pre-made analytics tools. Fine. These are the kind of reasons we might use these kind of things. So it's a great way for us to send our data. We can also use them to export data from Azure, meaning we can actually pull the information from Azure and then we could ship it somewhere else. Maybe we've got a lot of data on Azure. Maybe we made the mistake, which most organizations made, and thought that the cloud was going to be cheaper. And we didn't go to the cloud for its agility, which is worth it, but we thought it was going to be cheaper. Oh my God, it's so much more expensive. So we pull our information off of the cloud and back to our data center. Cloud repatriation. So there is that. And, people go to the cloud, back and forth to the cloud, up and down. And there's lots and lots and lots of good reasons to do this kind of stuff. So that might be the way we might want to do it. We might also want to use this, take the data off and put it on another cloud. So lots of reasons to use an Azure Data Box. But the data, when we use it, is taken off. And it uses this NIST 800-88 Romeo 1 standard after upload to sanitize it so your other data is not going to your data won't be seen by other people. We also have some file movement options. We've got these Azure file movement tools. So in addition to these Azure Migrate or Azure Data Box type environments, we have Azure tools which provide additional tools. We've got a tool called AZ Copy, Azure Storage Explorer, and Azure File Sync. I'll talk about what they are. AZ Copy is going to be a command line utility for copying blobs or files from your storage account. Not that different than those of us 20 years ago on our Linux system, FTP something or secure copy something to somewhere. That's really what we're talking about. Upload the files, download the files, that kind of thing. We could be using Azure Storage Explorer, and that's going to be a standalone app with a graphical interface to manage files or blobs. Works with Windows, Mac OS, Linux. But in the back end, it's going to be using that same AZ copy to copy you from point A to point B. Any of you used to use a file manager for FTP or secure FTP? Or, you open up all these windows on your Mac and you copy back and forth. Underneath, something is going on, but the simplicity is what we're typically talking about that graphical user of it. Now, Azure File Sync is going to be a way to centralize your file shares in Azure and maintain the same comportability of what you have and compatibility. So it'll turn your Windows file server into like a mini content delivery network. And what happens when you do this is it uses any protocol available on the Windows server to access data directly. So what does that mean? Well, maybe server message block, maybe FTPS, that kind of thing. It provides some global caching, and that way you can have multiple caches across the world to access your file servers. It helps provide server replacement. You can replace a failed local server by installing file sync on a new server in the cloud and the server in the data center. That'll keep them synchronized. And we can configure something called cloud tiering, which is going to keep the most frequently accessed files replicated locally, while infrequently accessed maintained on the cloud. So that would enable you to be in your data center, have a file server in the cloud, and make it feel like it's a local one through caching, or vice versa. Lots of opportunities here. So we're going to briefly talk about identity and access management. Now, for the last 20, 30 years, we typically think of Active Directory as your directory service. So what's a directory service? Well, Cindy the cat is a systems administrator who has access to this system, this system, this system, this system, and this system, but not these other systems. When Cindy the cat logs in, she's going to get a challenge. For example, she tries to log in and they send a message and says, please meow. She meows and it provides authentication by listening to the sound of the meow. I mean, we can authenticate via the iris scan if we wanted to, the fingerprint if we want to, the voice print. But in this case, Cindy's not so good with a keyboard, so we use a meow. That authenticates Cindy on the assumption that Cindy's meow sounds different than another cat's meow. Probably not the best solution, but there's that. She's a cat. So, but that is the authentication. The authorization is saying that Cindy can access this and this, but don't let her access these scary, serious things. And then the logging or the tracking or the accounting is Cindy went in, she walked on the keyboard with her paws. These are the things that she did. So you know what you did in case you caused a problem. And directory services are really just where you store that stuff. So in the data center, we use Microsoft Active Directory. In the cloud, they used to call it Azure Active Directory. I love this term. Why? Because we all knew what it was. But a lot of the cloud providers don't like to use the names of what the technology is, because then you'll realize that it's a 30 or 40 or 50-year-old technology that's been rebranded to sound exciting. So they make up new names. So Microsoft Enter ID is the Microsoft Active Directory on the Azure cloud. It is a cloud-based IAM service. It enables users to sign in and access Microsoft Cloud applications and custom deployed systems. We can integrate it to our on-premise Active Directory for a seamless sort of experience. And it is very good because it's based on Microsoft Active Directory type things at detecting suspicious logins and bad attempts. So it is a great identity and access management system. Very common that people have been using. So typically this kind of work is done by your systems administrators. They're the ones that are entering Sunny the cat versus the Cindy the cat and the permissions when people are hired. We can add functionality such as single sign-on. So once you log into one system or the main system, you don't need to log into other systems. We can manage passwords and self-service passwords, as well as administrators can restore a password. And we can also integrate this to Microsoft 365, Office 365, Azure, Microsoft Dynamics CRM. They're all able to authenticate with this cloud-based Microsoft Active Directory. So it provides authentication, supports multi-factor authentication, custom banned passwords, like you don't want Cindy the cat as a password for obvious reasons, and smart lockout devices, single sign-on, as I mentioned. We can manage cloud and on-premises apps. We can do things like application proxy, SaaS apps, My Azure Portal, single sign-on. And we can also register and manage devices through tools like Microsoft Intune and apply conditional access. Conditional access is really cool. Mike is in Port St. Lucie, Florida, so give me access to everything. Wait, my IP address is in Athens, Greece tomorrow, and that's not where my main home is, so limit my access. Of course, Athens, Greece, they would have to give me good access because I spend a lot of time in Nepetamos, Greece, but that's neither here nor there. But I'm not that often in Turkey. So if I logged in from Turkey, give me less access than if I logged in from my home in Greece or my home in Florida, that kind of thing. Turkey's a great place, spent lots of time there, absolutely love it, but you get the point. Conditional access is just that. And because we can connect our on-premise Microsoft Active Directory with our online Microsoft Azure Active Directory, rebranded Microsoft Enter ID, we've got a seamless identity experience. Log into one, that's going to work for another, etc. And we can synchronize our identities between these two. Multi-factor authentication, any of those kind of options we have. It can also provide domain services just like Active Directory. So when you log into a domain and you get access to certain things inside of that domain, like in the Windows systems, it does that. We can set you works with the group policy, LDAP, Kerberos type authentications. And here's the thing. It gives you access to directory service without having to manage Windows domain controllers. Why? Because they're probably managing it for you. So that way you get all those Microsoft Active Directory services with potentially a little less work. So some things to think about is you've got your own namespace. You define a domain namespace for your domain just like you would on Active Directory. When you use this, what do you think happens? They automatically deploy Windows domain controllers in a selected Azure region is something called the replica set. So the reason it's going to feel a lot like Active Directory is like the same people made it, and it's just a new name sitting in the cloud. So Azure handles all the domain controllers, backing them up, encrypting their disks, and you just manage the users and their permissions and that type of thing. Great in a hybrid environment because it can synchronize with the services in the cloud and without it. So now we're talking about authentication. Authentication is determining who you are again. So going back to our example with Cindy the cat enters her username and password. And then she gets asked to put a paw print on a paw print device reader. That's how we know that Cindy is Cindy. So we've got lots of options for authentication. We can use standard passwords. Okay, great. I got a couple of GPUs. I hack passwords pretty easily. I mean, I don't, but it can be done pretty easily. And poof, that's not the best thing. We have access to single sign-on. This is great. Sign into one system and don't have to sign into 20. Well, you gain some things because you don't have to manage 20 security passwords. You improve in productivity. But if you get access to the domain, you get access to all the systems. Could be good, could be bad. Evaluate the trade-offs and see what's right for you. Definitely have multi-factor authentication. And if it matters, we should be using multi-factor authentication, something you have and something you know. And we can also use passwordless identification, putting your thumbprint in, your fingerprint in, your eye scan, or in Cindy's case, her paw print, which is unique to Cindy. So here's the thing. Modern authentication methods reduce the risk of password breaches. I can tell you that back around 2000 and 2001 and 2002, the most common username and password on the internet were Cisco for the username, all lowercase, and Cisco passwords. Why? Because that's what Cisco taught on their labs. That's what you had to use on some Cisco exams. So everybody out there put the password, username, password, Cisco. That didn't work out so well. And the point is, it's very hard to control passwords. So if you can use something better, use a combination. Authentication is really about determining, are you who you claim to be? So am I Michael Gibbs versus someone else pretending to be me, Michael Gibbs? Or maybe there's another Michael Gibbs, but they're still not me. So verifying that you are who you say to be. Now that can be a person. It could be Cindy the cat. It could be one system trying to access another system. We still need to know that you are who you claim to be. And that prevents something like a man-in-the-middle attack, where I think I'm talking to Christopher Johnson from my team, but I'm not talking to Christopher Johnson. I'm talking to Hal the hacker, who's pretending to be the Christopher Johnson. That causes a major problem. So think about presenting your passport when you travel, in addition to your ticket, that kind of thing. So Azure supports pretty much anything you can think of with our from an authentication perspective. Single sign-on passwords, multi-factor authentication, fingerprints, eye prints, whatever you want. We talked about single sign-in and how that tends to make life easy. Prior to single sign-on, what I actually saw was people would have little sticky notes on their computers for all the systems they had to log into. Or they use the same password for all systems anyway, unless the systems police them out of it. Because how many passwords could people remember? Now we all use crazy password managers with 80-character passwords, and nobody even knows their passwords anymore. So, multi-factor authentication. This is using more than one. The traditional something you have, something you know, your ATM card. You want to go take out cash because your paycheck got direct deposited, and you want to take your friend to the bar and you want to pay cash for the meal. Or you're like me, you like to travel for cash and you like to pay cash for things. Call me Greek. That's what we do in Greece. We pay cash for everything. So I go to the machine, or I should say my wife goes to the ATM machine. She puts a card in. That's something she has. She enters a PIN number, which is something she knows. And then she says, here's Mike, here's the cash you asked for, and life is good. That is an old school multi-factor form of authentication. An RSA secure ID thing that's ticking that gives you a one-time password, a Google one-time password, something you have is that. Something you know might be a password or a PIN or what have you. So when we use multi-factor authentication, you might get asked a password. What can you call your credit card company? And they ask you the most ridiculous question: who's your mother's maiden name? And then you tell them your mother's maiden name. Well, that's public record. So if you have a credit card, please change your default password from your mother's maiden name. Something a user has. So when I try to log into some things, I get a text message on my phone that's got City the Cat on it. And that text message I then pop into things. Something I have on my phone. I've got other systems that I use my fingerprints for, my eyes for, depending upon what you want. The point here is it limits the impact of a credential. Fine, somebody got access to your password, but they can't do anything without it because they don't have access to your token or this. So it limits the challenge. Still change your password when someone get access to your password, but any level you can have, the better. So I mentioned we can have that. We can do, when we deal with these things, we have to think about a security and convenience trade-off. Passwordless authentication gives us very good security and a lot of convenience. Because if it's on a finger and you're using a fingerprint, you either have to be that person, you have to drag that person with you, or you have to cut the person's finger off and pop it in there. I mean, there are not too many ways to run around that. There are basically, you have to think about. So you have to think about, when you secure these things, what would the criminal attacker do? How would they access these systems? That's how you would access passwords. So hopefully none of the criminal activities, but at least just think about that. So when we deal with this, the key takeaways are: passwordless simplifies user management. It reduces the risk of credential-related security and improves for users. Now, if it's a fingerprint plus a password, that's better. But keep track of, at least you got other options. So let's talk about some more password lists. It removes the password and replaces with something you have. It could be a device or something you know. Ideally, mix the combination. So there's this concept of a Windows Hello for business. And you've got users with their own Windows PC. It uses a biometric like a fingerprint and a PIN number that's tied to the user's PC. We have an app like the Microsoft Authenticator app, which is like the Google Authenticator app, but the Microsoft version, which will turn your iOS phone or Android phone into something that's passwordless credential, and it'll come up with numbers and things, but you can deal with that. You can use a hardware device, a USB, Bluetooth, NFC, and that can handle authentication without usernames and passwords as well. So Azure AD support and Active Directory support conditional access. I mentioned earlier what that was. This is great. You're in the coffee shop, reduce access to systems compared to if you're in your home, where you have a point-to-point VPN with your router that's doing your security and what have you. You're traveling outside your your country, you reduce your access. If you're where you're supposed to be or normally, give you more access. So it really safeguards organizational resources, and we can look at the source IP address, what have you. We can get pretty granular with our conditional access. We can do multi-factor authentication. So for example, I'm home. I have a hardware Cisco router that's connected to the VPN. I'm coming from that IP address, which is known. Very simple. Log in with my username and password. Now I'm not at my IP address. Now I need a username, a password, and some form of additional authentication. So when we deal with conditional access, it's going to collect certain information during sign-on, such as your location, your device, the application. And then it's going to make a decision based upon whatever it's collected. Give me full access, block access, require a second form of authentication, what have you. It will enable the enforcement of decisions. So allow access or require a second form, block access. And if you think about this, and this really fits very neatly into the zero trust architecture of trusting nothing, but where are you? And okay, well, let's limit your access to this, but not this. So hope that kind of helps. We can even create a restricted or an approved list of applications. So all these applications can be accessed here, but When you want to connect to some special application, you can't connect it unless you're in the office or something. We have the ability to manage devices. So only if your device meets a certain security level, has a certain antivirus and patch level, can we use it. We can block unknown access from unknown locations. For example, let's say our business doesn't do business in China for whatever reason. I don't know. But maybe we have a product that's not legal in China. Well, then there's no reason to allow IP addresses from China inside your systems if you don't do business with China. That's that kind of block untrusted. Well, why would they be untrusted? Well, you don't do business there, so why is anybody accessing your system from there? Could be any part of the world, any country. I just make up names of countries and various people as we go along because, just looking for examples. So let's say, give some scenarios. A user's access from their normal location, give them full access. A user's in a high-risk location, well, block their access or require multi-factor authentication. A user's in an approved location, but not in a normal, full access. I try to sign in from the wrong computer, denied, that kind of thing. So that's conditional access, and it's quite good. Conditional access will enhance security because only trusted identities and devices are allowed to access the system. It's very flexible. We can set up a policy tailored to our needs. It enhances user productivity by ensuring that only legitimate users can access resources seamlessly while maintaining security. Some key takeaways here. It's got a strong identity systems, meaning who are you, where are they, and what device are they using. It's going to make a decision based upon the collected signals. It's got the option to enforce various actions, like you're allowed to execute something, you're denied. Or you want to do this, let me give you a challenge and see if you can respond to the challenge. And of course, there's some practical implications here as well. I'll briefly discuss role-based access control, then I'll take questions, and then we will finish for the day. So let's talk about role-based access control. What is it? And Chris, please drop the video in the chat box or the link to the video on role-based access control that I did, as well as identity and access management, because I want to make sure everybody truly understands these. So there's two ways that I could actually deal with my identity and access management. I want you to understand why we use role-based access control. Here's why. Let's say I have 200,000 people. Microsoft has about 250,000 people that work there. So we could have people, Mike Gibbs, new hire. He needs access to this, to this, to this, to this, to this, not this, and have somebody literally put for Mike Gibbs. Next person out of the 250,000. Cindy the cat needs access to this, 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 and this, but not this and this. So they put the persons. Christopher Johnson from Go Cloud Careers Net. And literally speaking, I'm not joking, and all 250,000 users. And as soon as someone gets promoted, is laid off, changes jobs, we're going to manually go change every permission for these 250,000 people. Now, that would be ridiculous. We'd need a staff of administrators that would be thousands of people just all day long entering this kind of nonsense. So we use what is called role-based access control as we think about job function. So systems administrators need this. Network administrators need this. Network engineers need this. Sales reps need this. So we create various roles. And then we give each job role access to whatever systems they need. And then when Mike Gibbs is hired among network architects, just stick me in the network architect's role. And poof, I have access to all the systems I need as a network architect. Less manual intervention. So it saves a ton on labor costs because we don't need to waste on people doing something silly. And at the same time, imagine having 250,000 users like Microsoft or 1.5 million users like Amazon and manually entering data all day and day long. How many errors do you think we would make? So this is an automated way to deal with these things. What if you're the U.S. military or the U.S. government with millions of employees? Going to have people all day do this, or we do role-based access control. So that's the reason. It's tedious to manage every individual. There will be mistakes that are made. So when we deal with these things, all our authentication systems typically have custom roles. reader, contributor, owner. I mean, common roles that exist. And maybe they work for your business. Maybe they don't. And if they don't, you build a customer role. So customer role, marketing executives, they need access to these systems, that kind of thing. So realistically speaking, that's how this works. We have to scope our role-based access control. So we have to think about what level the access control is going to be applied. Is it going to be collected to a managed group, say a collection of subscriptions? Is it going to be a single subscription? Is it going to be an Azure resource group? Or is it going to be a single resource like a virtual machine? And that scope definition is going to be critical. Now, typically speaking, in any form of access control, we have this hierarchy of the parent and the child. So what does that mean? It means if you assign an owner role to something, anybody inside that will typically get it. So, and I am not an identity and access management person because that's more of a sysadmin role. And I've been an architect. I've never had a sysman job. I never started with any of those more junior type roles. I've only taken senior roles in my 25-year technology career. Started as a senior engineer, and 3 months later, I was a lead architect. So when I left medicine. So here's the thing. If we've got a parent that's allowed everything. So if we've got a group that's allowed everything, and this includes the CEO, the CFO, the COO, and the CIO, and they're allowed everything. And underneath here, we have a group that's called CIO. They're allowed access to everything in that parent-child relationship, unless we do something about it. And that's kind of where that is talking about. But now if we had an everything group, and then we had a subgroup that says less rights for the CIO, then what would happen is the most restrictive policy would play. But generally speaking, if it's allowed in a group, anything in that subservient group will be allowed access to it. I hope that makes sense. But anyway, the point of role-based access control is you create a role, you assign permissions to the role, and then you assign users to that. And we do it because it's easy. It supports managing resources for large teams. It scales well. It's not labor and resource intensive, and we can get very granular for each job function of what people can do and what people cannot do. So let me take a few minutes of questions, or at least I'll do the best to answer the questions based upon what we have, based upon where they're at. I'm not an identity and access management person, but let's see if there's any questions before we leave for the day. Does the migration tool disrupt anything in the process, or is this a copy to a non-live system that is tested? So first, it's going to copy your system the way it is. And it's not going to change it or do any damage to what it's copying from. That's the first thing to remember. I think that actually answers your question. And then typically speaking, you're going to migrate it to a system for the cloud, and then you're going to test it. Because whenever you use a migration tool, it may or may not migrate things very nicely. For example, if I say "Close the fos" or "close the lights," that doesn't really translate very perfectly into English. Now, it might need to be changed from "Close the fos" or "close the lights" to "shut off the lights." So when we deal with going from one system to another system with migration tools, sometimes it's a little bit like translating a language, where some things just don't translate perfectly. And that's why it typically goes to a non-live system where you can test the workloads and tune them before you bring them into production. That is a really great question there, Benjamin. Yes, are there any others? Does Intune work for on-premise device management in a hybrid cloud environment? So Microsoft Intune can manage devices in a hybrid environment by integrating with Azure Active Directory and the configuration manager. And this typically allows for some form of a unified management of both cloud and on-premise devices, where you can apply policies and security settings across the entire information. What are some issues filtering with security groups, Azure AD, LDAPs, S, traffics? So I want to think about this for a second because I'm not a system admin where I would play with the Active Directory. So you could have some complexity in managing your resources. It may not be the easiest to have some fine-grained access for specific LDAP ports and users. And maybe you've got some limitations in your granularity. So security groups are typically user-based, not network-based or protocol-based. And that may make it a little easier, potentially, much more challenging. And maybe, and I have to think about this because this is not my area of expertise, but if we're going to do some kind of a network security group or a firewall for filtering some kind of LDAP thing, maybe we block some necessary communication pathways, which could cause a problem. But maybe blocking some of those essential LDAPs, communication ports, that kind of thing. So, not my area of expertise. These are what I'm kind of contemplating as we speak, but not my strength. So, I'm not 100% sure. That's what I can think about live and on the fly. Kind of hope that helps. Okay, well, let's do this. We have officially finished our first day of the official Azure training. Because you recall last week we went through more conceptual, we talked about things, we tried to make it very clear what they were. Chris just put a reminder and a link in the chat box for tomorrow's session. If you've had a good time, maybe like the video, subscribe to our channel, and hit the bell to be notified of new videos for your career. Definitely register for how to or get your first cloud job webinar on Thursday if you desire. It's free. We'll talk about the cloud architect role, the solution architect role. We can talk about the enterprise architect role if you desire, or anything you want. It's free. We'll talk for about 30 to 45 minutes, and then we'll answer as many questions as you can. I love always getting people to their actual goals there. And give me a hashtag Azure. So I know that you had a good time today. You're awake, alert, and oriented. Thank you so much for joining us today. I really love doing these kind of things. I love going out there with the community and meeting more people on a daily basis, and hope to meet